Welcome to Pratham Science Academy classes, and we are about to start with the set 5 of 2024. So this is set 5 of 2024, and this is subset 1 of set 5. So let's start with the first question, which says which is of section A, and this section has 20 MCQs, that is 1 markers. And the function f is defined from real to real numbers, which is f of x is equal to x squared minus 4x plus 5, and we have to check it for injective and surjective. So injective is also called 1 1, and surjective is also called onto. So that means we have to check this function for 1 1 and onto. Now this function is defined from a domain that has all the real numbers. So domain is real number and codomain is also a real number, and the function is defined as this function is f of x is equal to x square minus 4x plus 5. So let's check it for injective first, which means 1 1. So I'm going to check its validity for injective, which is also called 1 1. And for this, I'm going to take two elements in the real number, that is the domain. So let x1 and x2 be two real numbers that belong to the domain R, and let's say the image of f of x1 is f of x1 and the image of x2 is f of x2. So if x2 has it, x1 has a different image f of x1, x2 has a different image f of x2, then this function is an injective function. So what I'm going to do, I'm going to equate these two. So if these two are equal, so that means these two are not different, but these are also equal. So that means every unique image has a unique element in the codomain. So let's say if f1, I'm going to suppose this, if f of f1 if is equal to f of x2. So f of x1, we can get this from function. So just replace x1 in place of x. So which gives me x1 square minus 4x1 plus 5. This f of x2 is x2 square minus 4x2 plus 5. Okay. So 5 and 5 can be eliminated. So this is x1 square minus x2 square minus 4x1 plus 4x2 is equal to 0. And this is a square minus b square. I can write it as a minus b into a plus b minus 4 into a minus b. Okay, so if I take x1 minus x2 common, I am left with x1 plus x2 minus 4. So the product of two numbers is 0, so that means x1 minus x2 is equal to 0. So this means x1 is equal to x2. So in this case, if the images are same, then that means the elements in the codomain are also same. That means each element has a unique image. But let's also discuss this case. So in this case, we are getting that the function is 1 1, but it should be true for every case. So let's take this one, and let me put, let's say x1 is 0 or 1. Let me put x1 is 1. So if I put x1 is as 1 here, which gives me x2 is equal to 1 minus 4 is negative 3, which gives me x2 is equal to 3. And if I put, let's say x1 is equal to, I put here 3. So if I put 1 as 3, okay, if I put x1 is equal to 1, which gives me x2, and if I put x1 is equal to, let's say I put it as 0. So if I put x1 is equal to 0, which gives me x2 is equal to 4. Okay, let's check the value of f of x1 in this case. So now f of x1 is, sorry, f of f1. So if I find the value of f of 1, so f of 1 gives me the function is, this is 1 square minus 4 into 1 plus 5, which gives me 1 minus 4 plus 5 minus 3 plus 5 is 2. Okay, let's check it for 3 as well. So f of 3 is equal to 3 square minus 4 into 3 plus 5. So this is 9 minus 12 plus 5, which is equal to 2. Hello. Hello. Okay, which also gives me the value 2. So that means for, because x and 1 and 3 are real numbers, so for 1 we have this image 2, and for 3 we have the same image 2. So that means for two values in the domain, for two values of x, we are getting the same value of y. So that means the function is not 1 1. So function is not injective. If you plot the graph, you will also see that for some same two values of x, you are getting the same value of y. So this function is not injective. Now let's check it for surjective. Surjective function is also called onto function. Okay, and our function is f of x. So this f of x is x square minus 4x plus 5, and f of x means y. So y is equal to x square minus 4x plus 5. Let's try to get the value of x from here. So x is equal to y plus 4x minus 5. This is x squared, which gives me x is can be positive, negative. So x, okay, it's not the value of x. So I have to get the value of x in this case. So to get the value of x, let's try to uh, get this into a square. That is a minus b the whole square. So I'm going to multiply this 4 with half, which gives me 2. So let's add and subtract the square of 2 on both sides. So which gives me x square minus 4x plus 2 is x minus 2 the whole square. This is 5. 5 minus 4 is 1. Okay, so which gives me x minus 2 the whole square is equal to y minus 1. And I can write it as x minus 2 is equal to plus minus under root of y minus 1 and x. Now the value of x is, uh, let's take 2 to the other side. So x is equal to negative 2. This is 2 plus minus y minus 1. Okay, so here x has to be a real number. So if x has to be a real number, this value should be in the root of y minus 1 should be a real number, and this is possible only when this is greater than or equal to 0, which gives me y minus 1 is greater than or equal to 0, or y is greater than equal to 1. So y should be greater than or equal to 1, and y is greater than equal to 1 means y belongs to 1 to infinity. Okay, so this is now our codomain. Now this is the codomain is the real number. This is also the real number. But here, the range, our codomain is R. So codomain here is equal to R. But the range is only, this is the range. Range is only from 1 to infinity. So that means we are leaving the negative numbers. For all the negative numbers here, we for all the negative numbers here, we are not getting any value of x, such that f of x is equal to x squared minus 4x plus 5 uh, is equal to y. So here it's understood that the codomain is not equal to range, because codomain is a real number and range is only for the positive real numbers. So codomain is not equal to the range, and because for this function to be surjective or onto, codomain should be equal to range. So in this case, the codomain has all the real numbers and range is only limited to 1 to infinity. So these are not equal. So that means the function is not surjective. So the function is not surjective. So that means it's neither injective nor surjective. So at the end, the function is neither injective and nor surjective. So I have explained the process how to find 1 1 and how to check for 1 1 and on to say it's neither injective nor surjective. So option D is the correct one for this. So option D is the correct answer. For question number 2, it's given that A is a square matrix of order 3 and is a skew symmetric matrix, then find the value of 2A. Now, what is a skew symmetric matrix? Now, any square matrix of any order is said to be skew symmetric matrix when the transpose of the matrix is equal to its negative. So this is A. Let's find its transpose by changing the columns into rows or rows into column. So A transpose, this is A transpose will be equal to AB1. This is C0, negative 5, negative 1, 5, and 0. This is A transpose, and let's find out the negative of A by just multiplying all these with the negative. So this is A, C, negative 1, B, 0, and 5, and 1, negative 5, and 0. Okay, so this is A, B, 1, C, 0, negative 5, and negative 1, 5, and 0. Okay, this is now equal to negative A, negative C, 1, negative B, 0, negative 5, negative 1, 5, and 0. Okay, so these two matrices are equal, and if we equate them, so which gives me, if we equate these matrices, so which gives me B is equal to negative C, C is equal to negative B. So let's equate them. So A is equal to negative A. So A is equal to negative A. That means A plus A is equal to 0. 2A is equal to 0, which gives me A is equal to 0. Now B, uh, this is, okay. So B is equal to negative C. So B is equal to negative C means B plus C is equal to 0. Let this be equation 1. Now C is equal to negative B. It also gives me the same equation, and, and it's A, it's B, and this is okay. Let's equate this one. Uh, we have AB1 and okay. So we have got A is equal to 0 and B is equal to negative C. So okay, which gives us B plus C is equal to 0. Now let's find out. Okay, we were asked what is the value of 2A minus B plus C. Now A is 0, so let's put the value of A, which is 0, negative. Okay, B plus C. B plus C is also 0. So this is 0, which gives me the value as 0. So A is the correct answer for this one. So A is the correct answer. That is the value of 2A minus B plus C is 0. Okay, for question number 3, it's given that A is a square matrix of order 3. So the value of adjoint A is 8. Then what is the value of determinant of A transpose? Okay, there is, because it's a square matrix, and for square matrix of order n, there is a property for square matrix of order n. There's a property that says that the adjoint of A is equal to determinant of adjoint of A is equal to determinant of A raised power n minus 1. Now adjoint of A is given, which is 8, and n is the order is 3, so which gives me its square. 3 minus 1 is 2. Now determinant of A is equal to square root of 8, which gives me 2 root. Okay, now A is a square matrix. So for square matrix of any order, determinant of A is equal to the determinant of its transpose. So instead of A, determinant of A, I can also write determinant of A transpose. So determinant of A transpose is also equal to 2 root 2. So D is the correct option because for square matrix of order n, matrix of order n, the determinant of the square matrix is equal to the determinant of the transpose of the square matrix. So the answer is 2, which is option. For question number 4, it's given that if inverse of this matrix is this matrix, then what is the value of lambda? Let's say this is our matrix A, which is 7, -3, -3, -1, 1, 0, -1, 0, and 1. Let this be matrix A, and its inverse is given. So A inverse is given, which is 1, 3, 3, 1, lambda 3, 1, 3, 4. Okay, so this is A inverse. Now we have to find the value of lambda. So A and inverse is given, and we know that the, if we multiply A into A inverse, it gives me the identity matrix because it's for the invertible matrix that the A inverse exists. So let's get the product of these. Sorry. So this is 7, -3, -3, -1, 1, 0. And I say entry matrix of order 3, sorry, 1, 0, 0. Okay, this is 1, 0, 0, 0, 1, 0. So we have got the product. Now I can equate any one of these to get the value of lambda. So let me equate this to 0. So this is 21 minus 3 lambda minus 9 is equal to 0, which gives me 21 minus 9 is 3. So minus 3 lambda is equal to -3, which gives me lambda is equal to 1. So lambda is equal to 1, or let's check it once again. This is 7, -3, -3, -1, 0, 0, 1. And we have got this 7 into 3 is 21. This is -3 lambda, -9. And minus 3 lambda. Okay, 21 minus 9 21 minus 9 is 12. So 12 minus 3 lambda is equal to 0. Minus 3 lambda is equal to minus 12, which gives me lambda is equal to 4. So the value of lambda is 4, which means D is the correct option for this. Okay, for question number 5, it's given that the product of these two matrices is equal to this, then we have to find the value of x. So let's find the product first, and this is x to 0. We have to find its product with 5, negative 1, x. This is the second matrix. This is equal to 3, 1, and this is minus 2 by x. Okay, so let's multiply this. This is 5x, negative 2 and 0. So it will have only one element. This is 3, negative 2 plus x. Okay, so 5x minus 2 is equal to minus 6 plus x, because we have only one element in both these matrices. So which gives me 5x minus x is equal to negative 6 minus negative 2. So this is 4x minus 8, which gives me x is equal to negative 2. So x is equal to negative 2 is not the option available here. So let's check it once again. So this is 5x minus 2 and negative 6. This is negative 6, and this is 3, negative 6 plus 1 into x. So x to o 5. This is negative 6 plus, this is plus x. So 5x minus x gives me negative 6. This is plus 2. Okay, so this is negative 4, which gives me x is equal to negative 1. So negative 1 is the answer, which is option A. So A is the correct answer for this one. Okay, for question number 6, we have to find the square of the matrix A, where A is equal to Aij, which is a square matrix of order 2 whose elements are given by this. So actually, A matrix has its square matrix of order 2, so it has 4 elements: A11, A12, A21, and A22. So we have to get the elements A11, A12, A21, and how do we get this? This is a formula given. So it says that Aij is equal to, we have to get maximum out of, so this is max out of I and j, where I is the row and j is the column, minus minimum of ij. Okay, let's try to get all these elements now. So a at 1 1 is equal to max of 1 1 minus minimum of 1 1. So here max is 1 and minimum is 1, so a11 is 0. So we have got the first element, a11 is 0. Now let's get a12. So okay, a12 is max of the row and the column minus minimum of the row and the column. So this is minimum of the row and the column. So max out of 1 and 2 is 2, minimum out of 1 and 2 is 1. So this is A1. Now A21 is max out of 1 minus minimum out of 1. So max out of 1 is 2, minimum is 1. So this is also 1. And let's find out A2, which is also the max out of 2, 2 minus minimum out of 2, 2. So max out of 2, 2 is 2 minus 2 is equal to 0. Okay, let's put in the elements. A11 is 0, A12 is 1, A21 is 1, A22 is 0. So this is the matrix A. So A is equal to 0, 1, 0. And we have to find the square of A. So let's find out the square of A. So square of A will be, so if you have to find the square of A, we have to multiply this with 0, 1, 1, 0. And now multiplying this row with this column, 0 into 0 is 0, 1 into 1 is this is 0 into 0 is 0, and 1 into 1 is 1. Okay, 1. So 0 into 1 is 0, and 1 into 0 is 0. And 1 into 0 is 0, and 0 into 0, so this is 0, 1 into 1 is 1. So a square is 1001. A square is 1001. That means we have got the option C. So C should be the correct answer for this one. 0110. Check it once again. C is not the correct answer. 0110. If you multiply this, so this is 0 into 0 is 0 plus 1 into 1 is 1. Now 0, we have got the A matrix 0110. Okay, let's multiply this, and 0 into 1 is 0 plus 1 into 0 is 0. So next row, first column, 1 into 0 is 0 plus 0, 1 plus 0. So which gives me 001. So 1001. So 1001. And for this, our option is 1001 is the option C. So this is 1001, which is option C. So C is the correct answer for this one. Okay, for question number 7, it's given that x into e raised power y is equal to 1. Then we have to find its differentiation at x is equal to 1. So our given equation is x into e raised power y is equal to 1. So let's differentiate this with respect to 1. So differentiating this with respect to 1, we can we are going to use the product rule. So this is v, that is e raised power y into differentiation of x, which is 1, plus x into differentiation of e raised power y, which is e raised power y, and differentiation of y is dy by dx is equal to 1. Okay, this is now x into e raised power y into dy by dx is equal to negative e raised power y, which gives me dy by dx is equal to negative e raised power y upon x into e raised power y. This gets cancelled, and we finally have 1 by x. But we have to find the value of this differentiation at x is equal to 1. So let's substitute the value of x, which is 1, which gives me negative 1. And negative 1 means that A is the correct answer for this one. Okay, for question number 8, we have to find the derivative of e sine square x with respect to cos x. So let's consider them as u and v. So u is equal to e. This is sine square x, and v that is equal to cos x. Now, uh, because we have to find the differentiation of this with respect to this, so that means we have to find du by dv. And to get du by dv, because these are in the parametric form, so we are going to differentiate du with dx, and then dv with dx, and if we divide them, that should give me the required differentiation du by dv. So let's differentiate first this one with respect to x. So differentiating this with respect to x, it gives me du by dx, which is equal to the differentiation of e raised powers x is e raised power sine square x, and differentiation of sine x is 2 sine x. Differentiation of sine x is cos x. So this is du by dx. And differentiating this with respect to x, which gives me dv by dx is equal to negative of sine x. So let's do this, and we have to find differentiation of du by dv, which should be the division of du by dx by du by dx. So this is e raised power sine square x into 2 sine x into cos x. divided by negative of sine x. So this so now differentiation of du by dv is equal to, this is negative 2, let's write it at negative 2 cos x and e raised power sine square x. So this is the required differentiation, which is the option C. So option C is the correct answer for this one. Therefore, next question, we have to find the local minima for this function, and our function is f of x is equal to x by 2 plus 2 by x. Let's find out its first order derivative, which is, now the differentiation of x by 2 is 1 by 2 plus 2, and differentiation of 1 by x. I can write this as x raised power minus 1. So this is negative 1 into x raised power negative 2, which gives me f dash x is equal to half minus 2 upon x square. Now let's find out the second order derivative. So second order derivative differentiation of half is 0 minus 2. This x raised power minus 2 into x raised power minus 3. Okay, the second order derivative is now 4 upon x cube. Okay, let's find out the critical point for maxima or minima. For the maxima or minima, f dash x should be equal to 0. So f dash x is half minus 2 by x square is equal to 0, which gives me minus 2 by x square is equal to negative half, and x square is equal to 4. So x is equal to plus minus 2. So now let's check which is the point of maxima. So when x is equal to 2, f dash x, f dash 2, let's say it's f double dash 2 is equal to 4 upon 2 cube, which is equal to 4 by 8, and half, which is greater than 0. So this is a point of maxima. So at x, now x is equal to 2, is a point of maxima. We have to find the point of local maxima. So x is equal to 2 is a point of, is a point of local maximum, because for this the value of the second order derivative is greater than 0, and for x is equal to negative 2, the value of the second order derivative will be 4 by negative 8, which is negative half, which is less than 0. So this is x is equal to negative 2 is a point of minima. Sorry, this is a point of minima, and this is a point of maxima. So our answer is B. A is the correct option. Okay, for question number 10, it's given that there is a curve. Let's say this is the equation of the curve y is equal to 7x minus x cubed, and x increases at the rate of, so x increases at the rate of 2 units per second. That means it's dx by dt that is increasing at the rate of 2 units per second. Now we have to find the rate at which the slope of the curve is changing. Now the slope of the curve is given by dy by dx. So let's find out the curve. So dy by dx would be the differentiation of this, which is 7 minus 3x squared. Now dy by dx is the slope. So let's treat it as m. So 7 minus 3x squared. Now we have to find the rate at which the slope is changing. So that would be the differentiation of this with respect to t. So 7's differentiation is 0 minus 3, this is 2x into dx by dt. Okay, this is the rate at which the slope is changing when x is equal to 5. So rate at which the slope is changing when x is equal to 5 is now dx by dt is given, which is 2. So this is minus 30. Sorry. Before question number 11, we have to find the integration of 1 by x log x the whole square. So let's say our integral is I is equal to integral of 1 upon x into log x the whole square into dx. Okay, so we are going to use the substitution here. Let's substitute log x is equal to t, and differentiation of log x with respect to t is, this is 1 by x into dx by dt is equal to 1, which gives me 1 by x into dx is equal to dt. So this is dx. So 1 by x into dx means this is now equal to dt, and log x the whole square is t square. So this is now equal to t raised power minus 2 into dt. So this is of the form integration is x raised power n plus 1 upon n plus 1 plus c, which gives me t raised power negative 1 upon negative 1 plus c. So this is negative 1 by t plus c. Let's resubstitute the value of t, which was log x. So this is negative 1 by log x plus c. So negative 1 by log x plus c, that means B is the correct option here. Therefore, next question, we have to find the value of the definite integral, which is given as, and let's say this is our integral I, which is negative 1 to 1. So x into modulus of x into dx. Now we know that modulus of x is equal to x when x is greater than equal to 0, and negative x when x is less than 0. So that means our limits negative 1 to 1 are now divided in two intervals. So for this, I can write it as I is equal to 0 to, that is negative 1 to 0, for negative 1 to 0. That is when x is negative, the modulus of x is negative x. So this is x into negative x plus. Now this goes from 0 to 1. So this x is positive. So modulus x is positive. So this is x into dx. So this is dx. Now let's evaluate this. So minus I is equal to, this is negative 1 to 0, and this is negative x square into dx plus, this is 0 to 1 x square into dx. Okay, now I is equal to, let's take negative out. So integration of x square is x cubed by 3 for the limits 1 to 0 plus, this is also x cubed by 3 for the limits 0 to 1. Okay, now I is equal to negative, this is 0 by 3 minus 1 by 3 plus, this is 1 by 3 minus 0. Okay, now I is equal to, this is 0, so negative of, this will give me negative 1 by 3 plus 1 by 3, and this gets cancelled. Finally, the integral is 0. So 0 means we have this option D, so D is the correct option for this one. Okay, for question number 13, we have to find the area of the region bounded by the curve y square is equal to 4x, which is the equation of the parabola, and which opens up on the positive x-axis and x-axis being its axis. So let's say this is the x-axis and this is the y-axis, coordinate axis. Okay, okay. Now y square is equal to 4x is the equation of the parabola that opens up on x as its axis. So this is x-axis. So this parabola is symmetrical about x-axis. Let's say we have this coordinate 0 and 1 and 2. And we have to find the area of the region bounded by this curve. X-axis means this and x is equal to 0 means y-axis and x is equal to 1. So x is equal to 1 is a line that passes through the coordinate 1 on the x-axis. Okay, so we have to find the area of the region bounded by the x is equal to 0. This is x is equal to 1 and x-axis, that is, this is the region. And how do we find that? Let's consider this region to be made up of the rectangular components, and this strip has the length y and its width is d. So we are to find this y area that is between the x-axis and the region bounded by the parabola is equal to 1 and the x-axis. Okay, so this is equal to integration of 0 to 1 y into dx. Now y into dx is y squared is equal to 4x, so y is equal to under root 4x, which gives me y is equal to 2 under root x. So value of y is 2 under root x. So this is integration of 0 to 1 2 under root x into dx. 2 we can take it out, 0 to 1, and under root x I can write it as x raised power half into dx. Now integration of x raised power half is x raised power half plus 1 upon half plus 1 for the limit 0 to 1. So this is 2 into x raised power 3 by 2 upon 3 by 2, and this is now 4 by 3 into, for the limits 0 to 1, 4 by 3 into x raised power 3 by 2, 0 to 1. Okay, so this is 4 by 3 into 1 raised power 3 by 2 minus 0, which gives me 1. So actually this is 4 by 3 square units is the area of the required region. So this is 4 by 3 square units. 4 by 3 square units. And 4 by 3 square units means that D is the correct option here. So its answer is D. Right. Okay, for question number 14, we have to find the order of the differential equation. This is a differential equation. Uh, we have to find the order. Though its degree is not defined, but the order, the highest order of this differential equation, it's been differentiated 4 times. So the order is 4. Order is 4 because this equation has been differentiated 4 times. The order is 4, but the degree is not defined because this is not a valid differential equation. So degree is not defined. But since we are asked the order, so we will say that the order is 4. And do not check it for not defined because the degree is not defined, but the order is 4. So the correct option is A. Okay, for next question, that is question number 15. It's given that the position vectors of points P and Q are P vector and Q vector, and there is a point R that divides a line segment PQ in the ratio 3:1. So let's get our 3D space here. So this is the three perpendicular coordinate axes x, y, and z. And okay, so this is x, y, and z. Now there is a point P. Let's say this is a point P and this is a point Q, and their position vectors with respect to the origin are given. So their position vectors with respect to the origin are given. I'm going to join them as well. So their position vector of P with respect to O is P vector, and position vector of Q with respect to O is Q vector. Now there is a point S. There is a point S on PQ which divides the line segment in the ratio 3:1. Okay, now for a now the position vector of S will be OS. So this is the position vector of the point S, which is OS. Now it's given by M, a formula is M into B vector plus N into A vector upon M plus N, where M and N is the ratio. So M is to N is equal to 3:1. So let's put in the respective values. Instead of B vector, we have P vector. So this is 3 into P vector, and N is 1 into Q vector divided by M plus N is 4. 3 plus N, 3 plus 1 is 4. So this is 3P, and actually this should be B. So this is our A vector, and this is our B vector. So let me just change the values. So this is M. M is 3 into B. B is Q vector plus 1. N is 1 into A, which is P vector. So this is 3Q plus P, and 3 plus 1 is 4. This is the position vector of OS. 3Q plus P divided by 4. 3 into Q vector plus P vector divided by 4. Now there is a point S. Now this was actually point R. Sorry. This is actually point R. So this position vector is 1. Now S is the midpoint of line segment joining PR. So there is a point S which is the midpoint of PR. So the position vector of S, we have to find out the position vector of S. This was the position vector of. So S is the midpoint of PR. So the position vector of OS is equal to, it will be A vector plus B vector, that is A vector plus B vector divided by 2. Now A and B vectors are, A is the position vector of P, which is P vector, and B vector here is the position vector of R. So position vector of R is this. So this is 3Q plus P vector divided by 4, the whole divided by 2. And if we take, this is now 4P plus 3Q vector plus P vector upon 8. So this is the position vector of the midpoint S of PR. So this is 4P plus P is 5P vector plus 3Q vector divided by 8. So 5P plus 3Q divided by 8 is the option D. So D is the correct option for this one. Okay, for question number 16, we have to find the angle which this line makes with the positive direction of x-axis. And so we have two lines here. This is line, let's say L, which is given to us. Equation of the line L is given. So L is x1 is equal to y by -1 is equal to z by 0. And the direction ratios of this line, sorry, yes, the direction ratios of this line are, these are the direction ratios. So the direction ratios of this line are, these are the direction ratios, 1, -1, and 0. If we compare this with the standard Cartesian equation of the line, so this is A1, B1, and C1. These are the direction ratios of this line. So now the angle which a line makes with another line, and the other line is the y-axis. So let's find out the direction ratios of y-axis as well. Okay. Now this y-axis makes a angle with x-axis. Let's say this is alpha is 90 degrees, and the y-axis makes angle with the y-axis. Let's say beta is y-axis is makes angle 0 degree with itself, and y-axis makes angle with z-axis. This is also 90 degree. This is also 90 degree, and angle it makes with itself is 0 degree. So I have given them the name alpha, alpha, beta, and gamma. These are the angles that y-axis makes with x, y, and z-axis. With x-axis, it makes angle alpha, which is 90 degrees. So this is x-axis because these axes are perpendicular to each other. This is the angle that it makes with the y-axis. The y-axis with the y-axis makes angle 0. This is the angle it makes with z-axis. Let's say the gamma, which is 90 degree because y-axis is perpendicular to x and z-axis. And let me find out its direction. So cosines. So cos alpha, cos beta, and cos gamma are the direction cosines of the y-axis. So alpha is 90, so this is cos 90, which is 0. This is cos 0, which is 1. Gamma is cos 90, which is 0, which is 0. So these are the direction cosines of y-axis. So direction cosines of y-axis are 0, 1, and 0. Now, what would be the direction ratios of y-axis? So direction ratios of y-axis will be some number multiplied these direction cosines, and let me just multiply them with 1 because you can multiply any number, so which gives me the same result. So these are the direction ratios of y-axis. Let's say these are a2, b2, and c2. So now we have two lines. For the first line, that is this one, the given line, we have the direction ratios a1, b1, and c1, and the direction ratios of y-axis are a2, b2, and c2, and angle between two lines. So now we have to find the angle between the two lines, which is the given line, and the y-axis is given by the formula. Let's say which is cos theta, and is given by the formula. This is, if we write down the formula, this is a1 into a2 plus b1 into b2 plus c1 into c2 divided by the sum of the square of the direction cosines of the first line, its square root, into sum of the squares of some square root of the sum of the squares of the direction cosines of the second line. So if I put their values in here, so I have the direction cosines 0, 1, 0, in 0, 1, 0. So this is a1, b1, c1, and a2, b2, c2. Common here because so a1 is 0, a2 is 0, b1 is 1, b2 is 1, and 0 into 0. Okay, which also gives me this, or this is also root 1 into root 1. So that is equal to 1 upon root 1 is. Okay. This is a 1. So we have this negative 1. So this is negative 1 into 1, 0 into 0. And this will give me x. If we square this, so this will be negative 1 upon integration of 1. This find the square of square plus 2x plus 4 is equal to x. Multiply this with half, which is 1. Okay, let's me put in the values. Okay, so a1 is 0. Square of 1, so this is negative 1 square minus 1 is 3. Okay, this is not negative 1. This is the direction ratios here are 1, negative 1, and 0. And for the y-axis, it's 0, 1, 0. So which gives me, let me put in the values once again. So a1 is 1 into 0 plus b1 is negative 1 into 1 plus c1, 0 into 0 upon under root of a1 square, which is 1, and b1 square, which will be 1, c1 square is 0, under root this is 1. So which gives me this is minus 1 upon under root. Now, which gives me cos theta is equal to negative 1 by root 2. Now, cos is negative in the second quadrant, and the base angle for 1 by root 2 is pi by 4. So if we have to stay in the second quadrant for negative cos, that would be, I can write it as, so this is cos of pi minus pi by 4. So cos of pi minus pi by 4 will give me the value negative root 2. So which gives me cos theta is equal to cos, this will be 3 pi by 4. So that means theta is equal to 3 pi by 4. So theta is equal to 3 pi by 4 is the angle which this line makes with the positive direction of y-axis, and our answer is B. So B is the correct answer for this one, 3 pi by 4. Okay, for question number 17, we have to find the Cartesian equation of the line passing through the point and parallel to this line. So there is a line that is passing through the given point, and it's parallel to a line whose equation in vector form is given. Okay, so this line is, let's say, passing through the point 1, minus 3, and 2, and it's parallel to a line. So vector equation of this line is r vector is equal to 2 plus lambda into I cap plus lambda j cap plus 2 lambda minus 1 j cap. Okay, now we know that if we have to write the Cartesian equation of this line passing through a point is given by, so Cartesian equation of this line we have to find, and we know that the Cartesian equation of a line passing through a point x comma y comma z, and then parallel to b vector which has direction ratios ai cap, j cap plus ck cap. Let's say this is b1 is given by, so this Cartesian equation of this line is given by x minus, let's say these are x1, y1, and z1. So x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Now this point is given to us. It's passing to the point which is 1, negative 3, and 2. So let's put in the values here. So I'm going to replace the values of x1, y1, and z1, which will give me x minus 1 x minus 3 and this is 2. So our equation is x minus 1 by a is equal to y plus 3 by b is equal to z minus 2 by c. Now we have to get these a, b, and c's. Now this line is parallel to this line, and equation of this line will give us the direction ratios because we will try to get this in the form, standard vector equation form, which is a vector plus lambda into b vector. So we will get the b vector here. So because these two lines are parallel to each other, so they will be parallel to the same vector b vector is b vector. So let's get this converted in this form. So r vector is equal to, let me open this. This is 2 I cap plus lambda I cap plus lambda j cap. This is 2 lambda k cap minus k cap. Okay, now r vector is equal to, this is 2 I cap minus k cap. This is the position vector. And let me take lambda for all these common. So this is lambda I cap plus j cap plus 2k cap. And if we compare this with this one, if we compare these two equations, which gives me our parallel vector is I cap plus j cap plus 2k cap, and which gives me it A. The direction ratio is 1, B is 1, and C is equal to 2. So we have got A, B, C. So let's replace the values of A, B, and C here. So the required equation of line is x minus 1 by A and y plus 3 by 1 is equal to z minus 2 by 2. So our required equation is x minus 1 by 1 is equal to y plus 3, which is option D. So this is option D is the correct answer. Okay, for question number 18, is given that A and B are even such that probability of A by B. So it's given that probability of A by B is equal to probability of B by A. Now we know the probability of A by B is probability of A intersection B by probability of B. Similarly, B by A is probability of B intersection A by probability of A. Now we know that A intersection B or B intersection A. So one and the same thing. So these two we can cancel them, and it's 1 upon probability of B is equal to 1 upon probability of A, which gives me probability of B is equal to probability of A. We cross multiply them. So that means D is the correct option here. So G is the correct option for question number 18. Okay, for question number 19, it's assertion of the reason based. So assertion A says that domain of y cos inverse x is negative 1 by 1, which is true. And we know that the domain of cos inverse x is negative 1 by 2 with negative 1 to 1. It's a closed interval, it's true. Now its range for that is, now range belongs to 0 to pi, but it's given that it's 0 to pi minus pi by 2, which is false. So A is true and F is false, and also not the correct expression of A. So our option is option C. A is true, but reason R is false. So C is the correct option for this one. That is, A is true and R is false. A is true, but reason R is false. C is the correct option for this one. Okay, for question number 20, it's given for assertion the it is given that these vectors are the vertices of a right are represent the sides of a right angle triangle. And we know that the right angle triangle is the one in which one angle is 90-degree. And if these are the sides of this right angle triangle, that means uh, out of these two sides, uh, out of these three sides, two sides are perpendicular to each other. And if they are perpendicular to each other, that means that when the two sides are perpendicular to each other, two lines are perpendicular to each other, then the dot product is zero. So I'm going to find the dot product of A with B, B with C, and A with C. And let's say if it comes out to be zero in any of the cases, if it comes out to be zero, that means that these two sides are perpendicular and would be a 90-degree angle. So that would make this triangle the right angle triangle. So let me find out the dot product of AB, dot product of B into C, and dot product of A into C. A into C. Now dot product of A. So A is 6i cap plus 2j minus 8k caps dot product with B, which is 10i cap minus 2j cap minus 6k cap. So its dot product is the sum of the product of the scalar components respective 6 into 10 plus 2 into negative 2 plus negative 8 into negative 6, which gives me 60 minus 4 plus 48, which obviously will not be equal to 0. Let's find out the dot product of B and C. So dot product of B and C would be, this is 40 plus 8 minus 12, which is 48 minus 12, which is 36, which is not equal to 0. So that means these two are not perpendicular. These two are not perpendicular. Now let's find the dot product of A and C. So dot product of A and C, 6 into 4 is 24, negative 8, and negative 16. So 24 minus 8 is 16, minus 16 is equal to 0. So that means their dot product is 0. So that means A vector is perpendicular to C vector. So the sides representing A and C are perpendicular to each other. So that means this is a right angle triangle. So assertion is true. Now, let's move on to the reason. And what does it say? So three non-zero vectors of which none of two are coordinate forms a triangle, which is true. So let's say if there are two vectors, this is first vector and this is the second vector, if they are collinear. So let's say these are two vectors A and B and these are collinear. So if two vectors are collinear, if you take now the third vector in any direction, that's not going to form a triangle. So that means that none of two should be collinear, but will form a triangle, which is true. Okay, now it says that if the resultant is zero, once the triangle is formed, so three non-zero vectors of which none of two are collinear forms a triangle, which is true. Now, if their resultant is zero, so let's say we have this triangle uh, with the sides A, B, and C represented by the vectors A, B, and C. So let's say this is the triangle. This is A, B, and C. And this is vector, let's say A, this AB is represented by vector A, B, C is represented by vector B, and AC is represented by vector C. Okay, now these are the sides. Okay. Now, if their resultant is zero vector or sum of any two vectors is equal to third vector, if you use the triangle law of vector addition here, so which gives me this is AB plus BC should be equal to AC vector. Now the sum of n2 vectors is equal to the third vector, which is true, and the resultant is 0. So let's find out the resultant. So AB plus BC minus AC vector is equal to 0, which gives me AB plus BC. I can write this as negative of, this is AC vector is negative of CA vector. So now the resultant is 0, is 0. Okay. So three non-zero vectors of which none two of zero forms a triangle, which is true if the resultant is zero is also true, and sum of n two vectors is equal to the third side is also true. So that means assertion is true, reason is true, but this is not the correct explanation of A. So our option here would be both A and reason are true, but reason R is not the correct explanation of A. So our option should be option B for this one.
क्लास 11th वेस्ट हो गई है क्या? बहुत सारे बैकलॉग्स हैं, सवाल नहीं बन रहे, टेस्ट।
For question number 21, we have to find the value of k if sine inverse k tan 2 cos inverse root 3 by 2 is equal to pi by 3. So root 3 by 2, we know that it's uh, cos 30 is root 3 by 2, and 30 in terms of radian is pi by 6. So instead of root 3 by 2, I can write cos pi by 6, which reduces this equation to sine inverse k tan. This is 2 cos inverse. Instead of root 3 by 2, it's cos pi by 6, bracket close, is equal to pi by 3. Now, which gives me, this is sine inverse k, and this is tan, sorry, 2 into pi by 6 is equal to pi by 3. Sine when shifted to this side becomes, this is k tan of pi by 3 is equal to sine pi by 3. Okay, now tan pi by 3 means it's tan 60, which is root 3. Tan pi by 3 is root 3. Sine pi by 3 sine 60, which is half. Okay, sorry, sine 60 is root 3 by 2. Sine 60 is root 3 by 2, so which gives me the value of k as half. So the value of k is half. Okay, for question number 22, part A, we have to verify that the function is continuous at x is equal to 0, and this function is defined for at x on the real line as. So value of the function at x is equal to 0 is 0, and when it's not x, that is when it's less than x or greater than x, the function is defined as x into sine of 1 by x. We have to check its continuity at x is equal to 0. So at x is equal to 0, and let's the value of the function is 0, because 0 into something is 0. Now let's find out its left hand derivative, left hand limit. The left hand limit is given by limit x tends to 0 negative f of x, and f of x is, this is the function, and let's say x is equal to a small value less h less than x, and now when x tends to 0, h tends to 0, so this limit now becomes limit h tends to 0. X is 0 minus h, which is negative h, and sine of 1 upon negative h. So this is now equal to limit h tends to 0 and 0 minus h. Okay. Now we know that this sine of negative x can be written as a negative sine of x. So this becomes negative h into negative of sine of 1 by h, which gives us limit h tends to 0, h into sine of 1 by h. Now, if we take the limits, so h is 0 and sine 1 by h will be, now the value of sine 1 by h will be any value between from the interval negative 1 to 1. So this will take the any value from negative 1 to 1. Since we is going, whatever is the value is going to multiply by 0, so this is 0. So left hand limit is 0. Now let's find out the right hand limit. So right hand limit will be written as limit x tends to 0 plus, put in the value of the function when x is not 0, the value of the function limit x tends to 0 plus, this is x into sine of 1 by x. And let's suppose x is a small value h greater than 0, and when x tends to 0, h tends to 0. So this will give me limit h tends to 0, x is 0 plus h, which becomes h. And this is once again 1 by h. And if we take the limit, this is 0. And any value from the interval for sine 1 by h is negative 1 into 1, which ultimately will be 0. So that means the left hand limit is equal to right hand limit is equal to value of the function at 0 is 0. So that means this function is continuous at x is equal to 0. So this function is continuous at x is equal to 0. Okay, for next question, that is for 21st part B, we have to check the differentiability of the function defined by. So our function is defined by f of x is equal to modulus of x minus 5. Now we know that for the modulus function, if it's modulus x, it's x when x is greater than equal to 0 and negative x when x is less than 0. Similarly for this value f of x is equal to modulus of x minus 5 is equal to negative of x minus 5 when x is greater than when x is less than 5. So this is x is less than 5, and this value will be x minus 5 when x is, this will be positive when x is greater than equal to 0. So this is our function. So it's x minus negative of x minus 5, and when x is less than, it's okay, it's not 0, it's actually 5. It's 5. Because if we take, if x is less than negative 5, so this x minus 5 will be negative, and if x is greater than or equal to 5, this x minus 5 is positive. So finally, I can write this function as, so if I open this, this is now 5 minus x when x is less than 5, and x minus 5 when x is greater than equal to 5. Okay. Now let's check it for the differentiability. Let's find out the left-hand derivative and the right-hand derivative. So at x is equal to 5, let's find out the left-hand derivative. So left-hand derivative will be given by, the formula is its limit. It's written as x tends to x5 negative, and the formula is f of x minus f of a upon x minus a, and a here is 5, so this becomes limit x tends to 5 negative. This is f of x minus f of 5 upon x minus 5. So this is a. So this is now limit. So let's get the value of f of x, f negative. So f of x, because x is less than 5 left-hand derivative, so we will take the value, our function would be 5 minus x. So this is 5 minus x, f of x, and f of 5. If I put x as 5 in this, which gives me 0, so this is 0, and this is x minus 5, which this is x minus 5. Okay, I can write it as limit x tends to 5 negative, and if I take negative out, this is x minus 5 by x minus 5. This gets cancelled, and finally we have the limit for its negative 1, so the answer is negative 1. So that means the left hand derivative is equal to negative 1. Okay, now let's find out the right hand derivative. So right hand derivative will be written as limit x tends to 5 plus, and here it will be f of x minus f of a, which is 5 upon 5, sorry, which is x minus 5. So this is x minus a, which is 5. Okay, let's write down the value of x of. Now, for the right hand derivative, we are taking the value of x as greater than 5. And when the value of x is greater than or equal to 5, the function is x minus 5. So f of x is x minus 5, and f of 5 is 0. So this is 0 upon x minus 5, which finally gives me limit and leave it, and which gives me 1. So right hand derivative is equal to 1. So obviously here the left hand derivative is not equal to right hand derivative. So the function is not differentiable at x is equal to 5. So I can write that this function f of x is not differentiable and at x is equal to 5. Okay, for question number 23, is given that the area of the circle is increasing at a uniform rate of 2 centimeters square per second. So let A be the area of the circle, and it's given that rate of change of area is 2 centimeters square. We know that area of the circle is pi r square. So this is now pi is constant, which is out, and the differentiation of r square is 2r, and r would be dr by dt is equal to 2, which gives me, so rate of change of radius with respect to time is 1 upon r pi. This is centimeter per second. We have to find the rate of change of circumference. So let's find out rate of change of circumference. C with the circumference. Sorry, this is d by dt, 2 pi r. 2 pi is out, and this is dr by dt. So dr by dt is 1 upon r pi. This gets cancelled. So this is 2 by r centimeter per second, but we have to find the rate of change of circumference when r is equal to 5. This is 2 by 5 centimeter per second. Substitute the value of r as 5. So rate of change of circumference when radius is 5 is 2 by 5 centimeter per second. Okay, for question number 24, part A, we have to find the integration of cos of x to e raised power log of sine x. Now e raised power log of sine x is actually sine x. So I can write this integration at, let's say this is I. So this is cos cube x, and e raised power log of sine x is sine x into dx. Now it's ready for substitution, and let's make the substitution. Let's put cos is equal to t. So if I put cos is equal to t, so let cos x is equal to t. Now differentiating this with respect to t. So differentiation of cos x with respect to t. We are going to differentiate this with respect to t. So this is negative sine x, and x with respect to is dx by dt. Differentiation of t with respect to t is 1. So this is now negative sine x into dx is equal to dt. Or I can write this as sine x into dx is equal to negative dt. So instead of this, I can write here negative t, and this is t, so this is t cube. So finally, I is equal to negative is out, it's t cube into dt. Okay. Now t cube into dt, integration of t cube is t raised power 4 at 4 plus c. And finally, we can resubstitute the value of t, which was cos, so this is cos raised power 4x upon 4 plus c. This is the integration. For question number 24, part B, we have to, this is question number 24, it's part B, and we have to find the integration, and our integral is 1 upon, this is 5 plus 4x minus x square into dx. Now let's try to get this into some known form. So this is 5 plus 4x minus x square. If I take negative common in this, which gives me negative is common, so x square minus 4x negative 5. Okay, now let get this into a minus b the whole square by completing the square. So what I'm going to do, I'm going to multiply 4 with half, which gives me 2. So let's add the square, add and subtract the square of 2 in this. Okay, which gives me is now this, and this term is a minus b the whole square. So this is a minus b the whole square, and minus 5, 4 is minus 9. So this is minus 3 the whole square. So finally, I can write uh, this 5 plus 4x minus x square is equal to negative of this is now let me multiply this with negative, so which gives me 3 square minus x minus 2 the whole square. So our integral is now I is equal to integration of 1 upon this becomes this is 3 square minus x minus 2 the whole square into dx. Okay, now this is of the form a square minus x square. So let's write down the formula of integration of a square minus x square. So our formula for integration of a square minus x square. So we know that this is of the form integration of a square minus x square. So 1 upon a square minus x square into dx is equal to, the formula is 1 by 2a. So this is 1 by 2a log of a plus x upon a minus x plus c. Okay, we are going to use this formula on this integration. So this integration becomes, this is integration of 1 upon 2 into a, which is 3 into log of, this now becomes, okay, so let's apply this formula, which is 1 upon 2 into a. A is 3. So this is 3 log of a plus x. A is 3 plus x is x minus 2. And this is 3 minus a minus x, which is x minus 2 becomes x plus 2 when you open up the bracket. Okay. So finally, our answer is 1 by 6 log of, so this is 1 by 6 log of 3 minus 2 is, this is x minus 2. So the formula was a plus x upon a minus x. So this is x plus 1, or this, and now this can be written as 5 minus x plus c. So this should be the answer. 1 upon 6 log of 1 plus x upon 5 minus x plus c. Okay, for next question, that is question number 25, we have to find the vector equation of a line passing through the point 2, 3, negative 5 and making equal angles with coordinate axis. Okay. Now, these are x, y, and z axes. Now, the vector equation of a line passing through a point is given by a vector equation of a point passing through a given point, or the vector equation of a line is given by r vector is equal to a vector plus This is A vector plus lambda into B vector, where A is the position vector of the point through which it passes. This is the A vector, which gives me A position vector of this point is 2I cap plus 3J cap minus 5K cap. Okay, so if I put this here, which gives me the equation of the line as 2I cap plus 3J cap minus 5K cap plus lambda into B vector. This is a vector equation of the line. Now we have to find the B vector, and to find the B vector, there is a condition which shows that this line is making equal angles with coordinate axis. Let's say this is the line and it's making equal angles with the coordinate axis. So let's it angle with x-axis be alpha, and with the y-axis its angle be beta, and with z-axis its angle be alpha. So it's given that the angles are equal. So alpha is equal to beta is equal to gamma. If these are equal, then its cosine of these angles will also be equal. So cos alpha is equal to cos beta is equal to cos gamma. And we know that cos square alpha plus cos square beta plus cos square gamma is equal to 1, which gives me, so instead of, I can replace all of these with cos square alpha. So this is 3 times cos square alpha. So because these all are equal, so this is cos square gamma, this is cos square gamma is equal to 1. So that means 3 cos square gamma is equal to 1, which gives us cos square alpha is equal to 1 by 3. And so that means cos alpha is equal to plus minus 1 by root 3. So this is cos beta as well and cos gamma as well, because the angles are equal. So the direction cosines are also equal. So cos beta is equal to cos gamma is equal to cos alpha is equal to 1 by root 3. These are the direction cosines, and I can write it as plus minus 1 by root 3 plus minus 1 by root 3 and plus minus 1 by root 3. Okay, now let's find out the direction ratios, because B vector will be, so B vector is AI cap plus BJ cap plus CK cap, or A1, B1 and C1, where A1, B1 and C1 are the direction ratios. So let's get the direction ratios. Now the direction ratios are the M multiples. That is, if we multiply these with any number, you get the direction ratios. So I'm going to multiply this with root 3, which gives me 1 comma 1 comma 1 to make it simple. If we can also take the negative sign, and in that case you just multiply it with a negative 3, which will give us the direction ratios as 1 1 1. So that means B vector is equal to I cap plus J cap plus K cap. So we have got the direction ratio. This was A1 I cap plus B1 J cap plus C1 K cap, which gives me right cap A1 B1 C1. These are the direction ratios A1 B1 and C1, which gives me I cap plus J cap plus K cap. So let's put it here, which gives us the equation as 2I cap plus 3J cap minus 5K cap plus, and sorry, this is 2I cap plus 3J cap minus 5K cap plus lambda into B vector, which is I cap plus J cap plus K cap. So this is the vector equation of the line, which is 2I plus 3J minus 5K plus lambda into I plus J plus K cap. So this is the required, or the asked, vector equation of the line. Okay, for question number 26, part A, these are 6 short answer questions of 3 marks each, section C. This is question number 26, part A. We have to find the differentiation of the given equation. And because this is a function raised to the power function, so we are going to take log on both sides. So taking log on both sides we get. So this is log of cos x raised power y is equal to log of cos y raised power x, which gives us y into log of cos x, which is equal to x into log of cos y. Okay, now let's start the differentiation and let's use the product rule here. This is u into v. So this is, we are differentiating this with respect to s. So differentiation of y is dy by dx into log of cos x plus this is log of cos x, sorry, y into differentiation of log of cos x is 1 by cos x, and differentiation of cos x is negative sine x. Okay, similarly use the product rule here. So this is x into 1 by cos y. Differentiation of cos y is negative sine y, and differentiation of y is dy by dx plus. So next is log of cos y, and differentiation of x is 1. Okay, let's try to simplify this. So this is now, I can write it as dy by dx into log of cos x. This is negative y. Now sine by cos is tan x is equal to, this is x. Now sine by cos is tan, so negative x into tan y plus this is, sorry, into dy by dx. So this is sine by cos is tan negative x into tan y by into dy by dx plus log of cos y. Okay, let's take the dy by dx, the terms of dy by dx on one side. So this is dy by dx into log of cos x plus x into, yes, this is plus x into tan y into dy by dx is equal to log of cos y plus y tan x. And let's take dy by dx common here. So dy by dx is common, which gives us log of cos x plus x tan y is equal to log of cos y plus y tan x. Now we can write the dy by dx finally. So this is log of cos y plus y tan x divided by log of cos x plus x and y. This is the differentiation. So log of cos y plus y tan x upon log of cos x plus x tan y. Okay, for question number 26, part B. This is question number 26, part B. And it's given that if under root 1 minus x squared plus under root of 1 minus y squared is equal to a into x minus y, we have to prove this. Now, let's make some substitution here, because these are the functions under root, and we know that 1 minus x squared can be easily taken out of the root if we substitute this value with either sine or cos, because 1 minus sine square a will give us cos, and that will eventually take it out from the root. So let's make the substitution, and let's say substitute this value x. Let's say x is equal to sine a, and y, let's substitute the value of y with sine b. So both we are taking it sine, so which gives us, so if x is equal to sine a, then a is equal to sine inverse x, and b is equal to sine inverse y. Okay, now let's substitute the value here. So this is under root 1 minus sine square a plus under root 1 minus sine square b is equal to a into x, which is sine a minus sine b. Okay, 1 minus sine square a is cos square a, so this is cos square a under root plus this is under root cos square b, which is equal to a sine a minus sine b. Okay, this is now cos a plus cos b is equal to a sine a minus sine b. So let's use their formulas directly now. Cos a plus cos b. So cos a plus cos b is 2 cos of a plus b by 2 into cos of a minus b by 2 is equal to a. This is sine of a. Sine a minus sine b is cos a plus b by 2 and sine of a minus b by 2. So now cos of a plus 2, a plus b by 2, this gets cancelled, and finally we are left with cos of a minus, this is, I can rearrange it as cos of a minus b by 2 divided by sine of a minus b by 2 is equal to, okay, and actually this should be 2a, because sine of a minus sine a minus sine b. So sine a minus sine b is 2 cos of a plus b by 2, and sine of a minus b, sine a minus sine b is 2 cos a plus b by 2 into sine. So this is 2, 2 and 2 also gets cancelled. And finally this is a, so cos by sine is cot. So this is cot a minus b by 2 is equal to a. Okay. So cot a minus b by 2 is equal to a, which gives me uh, and this is now a minus b by 2 is equal to cot inverse a. And let's replace the value of, so a minus b, finally I can write a minus b is equal to 2 cot inverse a. Let's replace the value of a. A was sine inverse x and sine inverse y. So this is sine inverse x minus sine inverse y is equal to 2. This is 2 cot inverse a. Now, this looks like we can now differentiate this with respect to x. So differentiating this with respect to x, we get now differentiation of sine inverse x is 1 upon under root of 1 minus x square minus 1 upon under root of 1 minus y square, and differentiation of y is dy by dx. This is a constant, so its differentiation is 0. Okay, so this is now, I can write dy by dx is equal to, if I rearrange this, this is negative 1 upon under root of 1 minus y square is equal to negative 1 upon under root of 1 minus x square. This gets cancelled, and this is now dy by dx is equal to under root of 1 minus y square upon under root of 1 minus x square. Okay, so this is what was asked to prove. Okay, for question number 27, we have to find the second order differentiation at theta is equal to pi by 4, f pi by 4, and our given functions are x is equal to a sine cube theta and y is equal to b cos cube theta. So these functions are in the parametric form. This function is in terms of theta and theta. So let's differentiate them with respect to theta first. So dx by d theta is equal to a is constant. Differentiation of sine cube theta is 3 sine square theta. So this is a into 3 sine square theta. And the differentiation, because we are differentiating this with respect to theta, so differentiation of sine cube theta is 3 sine square theta, and differentiation of sine theta is cos theta. Differentiation of sine is cos theta. So this is a 3 sine squared theta into cos theta. Now let's differentiate this dy by So this b is constant out, so differentiation of cos is negative. Okay, it's sine square theta. So differentiation of cos cube theta is it's 3 sine square theta, and differentiation of cos once again, sorry, differentiation of this would be, so b is constant, differentiation of cos cube theta is 3 cos square theta, and differentiation of cos is negative sine theta. So this is dy by d theta, which is negative 3b cos square theta into sine theta. Negative 3b cos square theta into sine theta. Now let's find out dy by dx. And how do we find dy by dx? So dy by dx is dy by d theta divided by dx by d theta, which is minus 3b cos square theta into sine theta upon a into 3 sine square theta into cos theta. 3 and 3 gets cancelled. Okay, so finally we are left with dy by d theta is equal to minus b by a, and cos by sine is cos theta. So let's differentiate this once again. This is not dy by d theta, this is dy by dx. So let's differentiate it once again. Second order differentiation, minus b by a is constant, and differentiation of cot is negative cosecant square theta. So this is equal to b by a cosecant square theta. So this is the second order differentiation. Okay, and because we are differentiating this at, so this is the second order differentiation. We are differentiating this with respect to x, but this is in terms of theta. So this has to multiply it with, this is d theta by dx. Okay, now let's put in the value of d theta by dx. So that means this is b by a. Now it is b by a into cosecant square theta. Now d theta by dx. This is dx by d theta. So d theta by dx would be 1 upon. So this is 1 upon 3a into sine square theta into cos theta. Okay. Now b by a. Now cosecant square theta is 1 by this. I can write as sine square theta into 1 upon 3a into sine square theta into cos theta. And finally, the second order differentiation is d square y by dx square is equal to, this is b by 3a square, and I can write it as 1 by cos is secant theta into sine square is sine raised power 4 theta, so cosecant raised power 4 theta. Okay, but we have to find this second order differentiation when theta is equal to pi by 4. So this is b upon 3a square into secant pi by 4 into cosecant raised power 4 pi by 4. And now b upon 3a square secant pi by 4 is the reciprocal of cos pi by 4. So this is root 2 into cosecant pi by 4 is root 2 raised power 4, which gives me, so this is now b upon 3a square into root 2. So this root 2 raised power 4 means root 2 into root 2 into root 2 into root 2. So this is 2 2s are is 4. So this gives us 4b root 2 by 3a square. So 4 root 2b by 3a square is the second order differentiation at theta is equal to pi by Okay, for question number 28, part A, we have to evaluate this definite integral, and let's say our integral is I is equal to integral of 0 to pi. This is e raised power cos x upon e raised power cos x plus e raised power negative of cos x into dx. Okay, so we are going to use this property here because it's a definite integral 0 to a f of x into dx is equal to integration 0 to a f of a minus x into dx. Okay, so this will be equation 1, and using this property gives us I is equal to 0 to pi. Okay, so we have used this property, and now uh, cos of pi minus x is in the second quadrant where cos is negative. So this becomes I is equal to 0 to pi e raised power cos of pi minus x is negative cos x upon e raised power negative cos x plus e raised power, this will become negative of cos x will be positive into dx, this second equation. Now we are going to add 1 and 2, so 1 and 2 gives 2i. It is 0 to pi, and e raised power cos x denominator is same. So this is 2i is equal to 0 to pi 1 into dx, and once integration is x, this is 0 to pi, which becomes pi. So finally integral I is equal to pi by 2. This is I. So I is equal to pi by 2. Okay, this is question number 28, part B, and we have to find the integral. So let's use partial fraction method in this case. So 2x plus 1 upon x plus 1 the whole square into x minus 1 can be written as this is a upon x plus 1 plus b upon x plus 1 the whole square plus c upon x minus 1. Now we have to find the value of a, b, and c. For that, let's take LCM. So this is 2x plus 1 upon this is x plus 1 the whole square into x minus 1 is equal to this is now x plus 1 the whole square LCM and x minus 1. So which gives me a into x plus 1 into x minus 1 plus b into x minus 1 plus c into x plus 1 the whole square. So we can strike this off. And finally, we have 2x plus 1 is equal to a into this can be a square minus b square, b into x minus 1 plus c into x plus 1 the whole square. Okay, let's try to find the value of a and b. So if I put x is equal to negative 1, so this is 2 into negative 1 plus 1. If I put this is negative 1 square is 1, so 1 minus 1 is 0. This term reduces to 0. This becomes negative 2b, and this becomes 0. So this is negative 2 plus 1 is negative 1, negative 2b, which gives me b is equal to half. Okay, and if I put x is equal to 1, so which gives me 3. So this is 2 into 1 plus 1, 3. So 1 square minus 1, this is 0, this is 0, and this becomes c1 plus 1 is 2 square into 4, so c is equal to 3 by 4. Now let's put x is equal to 0 in this equation, which gives me 2 into 0 is 0, 1 is equal to x is 0, 0 minus 1 is negative a, and 0 minus 1 is negative b plus c. Now we have the values of b and c, so negative a, b is negative, b is half, c is plus 3 by 4, which gives me 1 is equal to negative a, this LCM 4, this is negative 2 plus 3, so 1 is equal to negative a plus 1 by 4, a is equal to 1 minus 1 by 4, sorry, yes, a is 1 minus 1 by 4, which is 4 minus 1 is 3 by 4. So 1 minus is not actually, this is, let's say, negative a is equal to 1 minus 1 by 4, which is 3 by 4. So a is equal to negative 3 by 4. So a is negative 3 by 4, b and c we have got the values. So that means I can write this integration as a upon x plus 1. A is negative 3 by 4. So this is negative 3 by 4 upon x plus 1 plus b. Now b is half. So this is half of x plus 1 the whole square plus c. C is 3 by 4. So 3 by 4 into x minus 1 into dx. So finally we have got our integral in this form, and let's separate this. So this becomes minus 3 by 4 integration of 1 upon x plus 1 into dx. This is half integration of 1 upon x plus 1 the whole square plus 3 by 4 integration of 1 upon x minus 1 into dx. Everything is with the differential element dx. Okay, so this is log of minus 3 by 4 into log of x plus 1. This is log of x plus 1, and we have to differentiate this. This is x plus 1 the whole square, and differentiation of this x plus 1 the whole square is uh, let's differentiate this. So this one, if I differentiate this x plus 1, so x plus 1 the whole square, I can write it as x plus 1 raised power negative 2. So integration of this is now x plus 1 raised power negative 2 plus 1 upon negative 2 plus 1, which is negative 1 up, which is equal to negative, and x plus 1 raised power negative 1, so minus 1 upon x plus 1. So this integration is, I will have to put a negative sign here. So minus half into 1 upon x plus 1. So this is the integration of x plus 1 the whole square using the formula x raised power n, integration of x raised power n. So negative half into x plus 1. Okay, and the last one, this is 3 by 4 into log of x minus 1. So this is the integration, and let's try to simplify it further. Okay, so for these two, I can take 3 by 4 common. So if I take 3 by 4 common, which gives me, this is log of x minus 1 minus log of x plus 1, and this is minus half of x plus 1. Okay, and don't forget to add c when the integration is done. C. Okay, this is now log a minus log b, which is log a upon b. So 3 by 4 into log of a upon b. is log of x minus 1 upon minus half of x plus 1 plus c. So 3 by 4 log of x minus 1 upon x plus 1 minus half x plus 1. This is the integration. Okay, for question number 29 part A, we have to find the particular solution of the differential equation. So our differential equation is this, and if we compare it with dy by dx plus dy is equal to q. So if we compare these equations, we can get the value of p and q. And so here p is equal to negative 2x and q is equal to 3x squared into e raised power x the whole square. Okay, now let's get our integrating factors. So integrating factor is equal to e raised power integration of p into dx. So this is integration of e raised power negative 2x into dx. Negative 2 is out. Integration of x is x squared by 2. This gets cancelled. So this is e raised power negative x squared is the integrating factor. Now we have to write down the general solution. So general solution is given by the formula. So in this case, when the equation of the form dy by dx plus py is equal to q, general solution is given by its y into integrating factor is equal to integration of integrating factor into q into dx. Okay, let's put in the respective values. Y into integrating factor is e into x raised power negative x square, e raised power negative x square into q. Q is 3 x square into e raised power x square. Okay, e raised power x square. So which gives me, so this reduces to 0. I'm only left with 3x square. So this is y into e raised power negative x square. Now if we add these powers, negative x square plus x square, so e raised power negative x square plus x square is 0, and this is 3x square. So this is 0 and anything to the power 0 is 1. So finally we are left with y into e raised power negative x square is equal to integration of 3x square, 3 is out, and this is x square into dx. So integration of x square is x cubed by 3 plus c. Okay, so this is 5y into e raised power negative x square is equal to x cubed plus c. Okay. Now, when x is equal to 0, y is 5. It's given that when x equal to 0, y is equal to 5. So let's get the value of c. And when x is equal to 0, y is equal to 5. And if you put the values here, so y is 5, so this is 5 into e raised power negative e raised power 0 is equal to x cube is 0 cube plus c. So this gives me c is anything to the power 0 is 1, so c is equal to 5. So c is equal to 5, and now finally our particular solution is y into, this is y into e raised power negative x square is equal to x cube plus 5. This is the particular solution. Y is equal to x cube, or let me just, I can also write it as y is equal to, if I take this to the other side, this becomes positive. So this is x cube plus c into e raised power x square. This could also be the solution. So y is equal to x cube plus 5 into e raised power x square. Okay, for next question, that is question number, this is 29th part B, and we have to solve the following differential equation. This is question number 29, part B. We have to solve the following differential equation. And to solve this differential equation, let's try to get this into some known form, that is into the linear differential equation form. So I'm going to divide each and every term by dx by x square. So let's divide this x square into dy by x square into dx. Similarly here, I can write it as yx. This is y. Okay, let me first of all divide it. So this is y into x plus y into dx. So divided by x squared into dx is equal to 0. This becomes dy by dx plus this is now y on x square plus y square upon x square is equal to 0. And finally it can be written as dy by dx is equal to negative or plus y upon x. This can be written as plus y upon x, or let's take it to the other side. This is negative y upon x, negative y upon x square. Okay, let's make the substitution here. Let's say this is our first equation. Let's make the substitution so that y upon x is equal to v, which gives me y is equal to vx. And now I'm going to differentiate this with respect to x. We get, so differentiating this with respect to x, we will get dy by dx is equal to v to differentiation of x is 1 plus x into dv by dx. Let this be equation 2. And if we compare equation 1 and equation 2, so this is now v plus x into dv by dx. This becomes negative v square. Okay, so we have v plus x into dv by dx is equal to negative v minus negative v square. So we can separate the variables and integrate. So let's separate the variables. So this becomes x into dv by dx is equal to, this is negative 2v minus v square, and this is dx by x, and this can be written as dv upon and negative 2v minus v square. So finally we have separated the variables. So we can also take the negative out of here and shift this to the other side. So if I take negative out from here, so I can write this as dv upon 2v plus v square is equal to negative of dx by x. And now let's use the integration on both sides. So if we use the integration on both sides, or applying the integration on both sides, we get, this is the integrating on both sides. So this is the integration of dv upon 2v plus v square is equal to integration of dx by x. Okay, we can get this into the a plus b the whole square form. So I'm going to add, so multiply this 2 with the half, which gives me 1. So just add and subtract the square of 1. So these three terms will become v plus 1 the whole square minus 1 square. So instead of this integration, I can write v plus 1 the whole square minus 1 square into dv is equal to, this is now negative of log x plus, I can take it as log c. Okay, now this integration is of the form, I'm going to use here the formula, which is 1 upon integration of x square minus a square into dx. And x square minus a square into dx is 1 by 2a into log of x minus a upon x plus a. So let's try to use this 1 by 2 in log of x minus a upon x plus a. Okay, so if we apply this here, now becomes 1 by 2 into a. A is 1 into log of x is v plus 1, v plus 1 minus 1 upon v plus 1 plus 1. And this is equal to, this is log a minus log b, which is log of a upon b. So this is half log v upon v plus 2 is equal to log of c by x. So we finally have log half log v upon half log v upon v plus 2 is equal to log of cx. And this was to be this, we have to solve the following equations. It's not a particular solution we have to find out. So we'll just replace the value now. So this is half log v was, we have, let's resubstitute the value of v, which was y by x. So this is y by x upon y by x plus 2 is equal to log of c by x, and which gives me half log, this is y now. If I take LCM, this is y plus 2x is equal to log of c by x. Okay, and okay, so this is half, and half means I can use it as a power here, half, and half means the square root, and if we have to take it out, then we have to square on, this is the square root. So that means now we can take off the log, and this is y upon y plus 2x half is equal to c by x. Let's square on both sides. The square on both sides will take off the half. Square on both sides, we get, if we square on both sides, so if we square on both sides, this gets cancelled, and this is c square upon x square. So this is y upon y plus 2x is equal to c square by x square. And let's now cross multiply this, and I can write it as x square y is equal to c square into y plus 2x. Let me assume that this c square be k, constant k, so x square y is equal to k into y plus 2x. So this is the general solution. So x square y is equal to k into y plus 2x. Here for question number 30, we have to find a vector of magnitude 4 units perpendicular to each of the vectors. So this is question number 30, and let's say these are the vectors a and b. So let's say c vector is perpendicular to uh, a vector. First one is a vector y cap minus j cap plus k cap, and the second one, let it be b vector I cap plus j cap minus k cap. Now if c is perpendicular to, now c is perpendicular to a and c is perpendicular to b, so now c is equal to a cross b. So let's find out a cross b. So a cross b is I j k cap determinant, and 2 negative 1 1 1 1 and negative 1. This is why, this is how we find a vector that is perpendicular to, if a vector is perpendicular to these two vectors, then that vector is the cross. We can get that vector by getting the cross product of those two vectors. So this is now I cap, and the determinant of, we're left with negative 1, 1 and negative 1, negative j cap, and remove the row and the column for j. It's 2, 1, 1, negative 1 plus k cap. It's 2, negative 1, 1, and 1. Okay, for this is now I cap. Negative 1 into negative 1 is 1, 1 minus 1, minus j cap. Negative 1 is negative 2 minus 1 plus k cap. 2 into 1 is 2. This is plus 1. And these all are brackets. Okay, so this is bracket. This is also bracket, and this is bracket. 1 minus 1 is 0, so I cap is gone. So this is 3j cap plus 3k cap. So this is the vector. Now, vector that has magnitude 4, this vector should have, vector has magnitude 4 and perpendicular to A and B should be equal to 4 into unit vector of C. So 4 into, let's find out the unit vector of C. Unit vector of C is C vector divided by its magnitude. So this is 4 into C vector. C vector is 3j cap plus 3k cap divided by its magnitude, which is 3 square is 9 plus 9. This is equal to 4 into 3j cap plus 3k cap under root 9. So this is 18, which gives me 3 root 2. So finally, this is 4 into 3 by 3 root 2 j cap plus 3 by 3 root 2 k cap. Okay, 3 and 3 gets cancelled. So this vector, the vector that has magnitude 4 and perpendicular to A and B is equal to 4 p cap. So this is equal to 4 into 4 by 2. This is 4 by root 2 j cap plus 4 by root 2 k cap. And if we rationalize this 4 by root 2, so 4 by root 2, if we rationalize this, it becomes 4 by root 2 by 2, that is 2 root 2, which is 2 root 2 j cap plus 2 root 2 k cap. This is a vector that has magnitude, and let's say this vector BD vector. Now we have to verify the results. So first of all, let's find out its magnitude, which should be 4. So magnitude is 2 root 2 the whole square plus 2 root 2 the whole square under root. So 2 root 2 the whole square is 2 to the 4 to the is 8. 8 plus 8 is 16, which is 4. Now let's make sure that this vector is perpendicular. So let's find out the dot product of D with A. So this is 2 root 2 j cap plus 2 root 2 k caps dot product with A. And A vector was 2I minus j plus k. This is 2I cap minus j plus k cap. So if I find its dot product, so this is 2 root 2. This is negative 2 root 2 plus 2 root 2, which is equal to 0. So that means this D vector, which has magnitude 4, is perpendicular to A vector. Now, similarly, if we find the dot product of D with B, so this is 2 root 2 j cap plus 2 root 2 k cap, its dot product with the B vector. If it's 0, that means it's perpendicular to B as well. So I plus j minus k. So this is I vector plus j vector minus k vector. And this is 2 root 2 negative 2 root 2 negative 2 root 2, which is equal to 0. So that means D vector is perpendicular to vector. So D vector is perpendicular to B, it's A, and its magnitude is 4. That means we have verified the result. Okay, for question number 31, it's given the random variable has the following distribution, where A and B are some constants, and random variable has the values 1, 2, 3, 4, and 5, and probability of these random variables at x is equal to 1 is 0.2, and respectively for 2, 3, 4, and 5. It's given that mean is 3. So we have to find the values of A and B. Now the mean is 3, and how do we find the mean? So mean is actually the summation of pi into xi, and I goes for here, the I goes from 1 to 5, where it takes the value of the random variables, and this is equal to 3. So this is actually the summation of that is the sum of the product of the random variable and its respective probability. So let's uh, get that. So 1 into 0.2 plus this is 2 into a, which gives me 2a, plus this is 3 into a. So 3a plus 4 into zero point 0.2 is zero point 0.8, plus 5 into b is 5b, is equal to 3. Okay, this is now zero point 0.2 plus 2a plus 3a is 5a, plus zero point 0.8 plus 5b is equal to 3. Now zero point 0.2 plus zero point 0.8 is 8 is 1. So we get 5a plus 5b is equal to 3 minus 1 is 2. So this is our first equation. Now to find the value of these two variables a and b, we should have second equation as well. And to get the second equation, we know that the sum of the probabilities of all the events is equal to 1. So that means we can add these sum of probabilities of all events is equal to 1. That means the probability of x is equal to 1. These are the probabilities. Let's add them. So zero point 0.2 plus a plus a plus next is zero point 0.2 plus b should be equal to 1. So zero point 0.2 plus zero point 0.2 is zero point 0.4, and a plus a is 8. This is 2a plus b, and 1 minus zero point 0.4 is zero point 0.6. So this is our second equation. So let's try to solve them. So 5a plus 5b is equal to first equation, and 2a plus b is equal to zero point 0.6 is the second equation. And these are the first and the second equations. For first equation, let's multiply this with 2, and second equation, let's multiply this with 5, which gives me 10a 10a plus 10b is equal to 4, and this is 10a. This is 10a, 10b. This is also 10a plus 5b is equal to 3. This is zero point 0.6. Okay, let's subtract these equations. And 10b minus 5b is 5b, 4 minus 3 is 1. So b is equal to 1 by 5. And if b is equal to 1 by 5, let's get a. So once again, now we have got b. And now I'm going to multiply these two equations. Let's multiply first with 1 and second with 5. So first will remain as it is, 5a plus 5b is equal to 2. And this is now 10a plus 5b is equal to 3. Okay, subtracting these two equations once again, this is now negative 5a is equal to negative 1, which gives me a is equal to 1 by 5. So we have got the values of a and b, which is 1 by 5 for both. Okay, now in this question, it's further asked, we have defined the values of a and b. We have got that, and hence determine the probability of when x is greater than equal to 3. So probability when x is greater than equal to 3 means probability when x is equal to 3 plus probability when x is equal to 4 plus probability when x is equal to 5. Okay, so 3 for 3, the probability is a. So this is equal to a plus zero point 0.2 plus point b from the table. A is 1 by 5.2 and B is also 1 by 5. 1 by 5 is zero point 0.2. So this is zero point 0.2. I can write it as zero point 0.2 plus zero point 0.2 plus zero point 0.2, which gives me 0.6. So this is the probability for x is greater than, whether in a variable has a value, x is greater than equal to 3. Okay, for next question, these are four long answer questions in this section, and each section is of 5 marks each. So this is the first part of question number 32, and A is a square matrix of order 3. We have to find A inverse and hence solve the following system of equations. So first of all, let's find out A inverse. And to find out A inverse, so we know that formula for A inverse is adjoint of A by determinant of A, and we have to check where find out determinant of A and adjoint of A. Let's find out determinant of A. So I'm going to expand this long row, second row, because we have 1 0 in this. So this is plus and negative. So the first one is negative 2, and removing the row and the column for this, we are left with 2, negative 3, 2 and 0. Second one, we need not have to take 0, just go to the last one. So this is positive, negative. So this is negative of negative 3. And removing the row and the column for negative 3, we are left with 1, 2, 1, 2. Okay, so determinant of A is equal to negative 2. 2 into 0 is 0. Minus 2 into negative 3 is negative 6. This is plus 3. 1 into 2 is 2. Minus 2, which is 0. Okay. Okay. Now, determinant of A is equal to, this becomes 6. This term is 0. So this is negative 12. So negative 12, which is not equal to 0, that means A inverse exists. Okay, now let's find the adjoint of A. To find the adjoint of A, so I have got a determinant of A, which is negative 12. So let me just simply write it here. I'm going to erase this. So determinant of A is negative 12, and I'm going to now find adjoint of A, for which let's find the cofactors A11, A12, and A13. And this is where I'm going to write the adjoint of A. So A11, A12, and A13. And let's assign the sign to them first. So 1 plus 1, adding the row and the column, 1 plus 1 is 2, which is even. So let's put the positive sign. For odd, we put the negative sign, and it's even. Now remove the respective row and the column for element in the first row and first column. So if I remove this, the determinant is 0, negative 3, 2, and 0, which gives me, this is 0 and negative 6. The second one is removing the row and the column for second one. So we are left with 2, negative 3, 1, and 0. So this is equal to negative 2 into 0 is 0, and negative of negative 3, 0 minus 3, which gives me negative 3. Okay, for 1, 3, it's removing the row and the column for this one, it's 2, 0, 1. So 2, 0, 1, 2, which gives me 4 minus 0, which is equal to 4. So we have got the cofactors for the first row, and we are going to write them in the column here. So this is negative 6, negative 3, and 4, because adjoint is the transpose of the cofactor matrix. So negative 6, 6, negative 3, and 4. And actually, this should be 6, because 0 into 0 is 0, minus of minus 6, which gives me 6. So this is 6. Okay. Similarly, we can get the cofactors of the second row. And cofactors of the second row are for 2, 1, 2, 2, and 2, 3. So 2 plus 1 is 3, which is also negative. This is positive, and this is equal to negative. Okay, 2, 1. So this is element in the second row and first column. So this is 2, negative 3, 2, and 0. So removing the second row and the second column. So removing the second row and the second column, it's if you remove the element in the second row and second column, it's 1, negative 3, 1, and 0. 1, negative 3, 1, and 0. And this is if you remove the row and the column for the third one, suppose 1, this is 1, 2, 1. So 1, 2. Now this is equal to negative 2 into 0 is 0, negative of negative 6, which is equal to negative 6. This is equal to 0 minus of minus 3, which is equal to 3. And this is equal to 2 minus 2 negative, which is equal to 0. So this is negative 6, 3, and 0. Okay, now let's find out the cofactors for the third row. Okay, so third row means 3, 1, 3, 2, and 3, 3. So 3, 1, it's plus, it's negative, and it's plus. Let's remove the row and the column here. So if you remove the row and the column for this, 2, negative 3, 0, 3. This is 2, negative 3, 0, and negative 3. For the 3, 2, for 3, 2, it's 1, negative 3, 2, and negative 3. Okay, for 3, 3. If you remove the row and the column for this, we are left with 1, 2, 2, 0. 1, 2, 2, 0. Okay, now it's negative 6, negative of, this is negative 6 because 0 into 3 is 0. This is negative of negative 3 minus of minus 6, which gives me negative minus 3 plus 6, which is equal to negative 3. And this is negative 4. So negative 6, negative 6, negative 3, and negative 4. This is the adjoint. So we have got the adjoint of A 6, negative 6, negative 6, negative 3, 3, negative 3, 4, 0, negative 4. And let's find out now the A inverse. Okay, now we have got determinant of A, we have got adjoint of A, and we have to find A inverse, which is adjoint of A matrix divided by the determinant, which is negative 12. So this is negative 1 by 12, and 6, negative 6, negative 6, negative 3, 3, and negative 3, 4, 0, and negative 4. This is A force. Now using this, we have to solve this system of equations, and we know that this system of equations, we can write it in the matrix form as Ax is equal to B, where x, which gives me x is equal to A inverse B. Now, has the variables, X matrix has the variables X, Y, and Z, and we have the A inverse, which is minus 1 by 12, and which should be 6 minus 6 minus 6. This is negative 3, 3, negative 3, 4, 0, and negative 4. Okay. And we have to multiply this with the A matrix, sorry, B matrix. B is a matrix that has the constants, which are 1, 2, and 3. So this is 1, 2, and 3. Okay, so let's find the product of this, which is 6, negative 6. Okay, we are ready to find out the product. So how do we find out the product? So let's keep it out. So we have to find the sum of the product of the respective elements of the row and the column. So 6 into first element is 6 into 1, and then minus 6 into 1 and minus 6 into 2, which is negative 12. Once again, negative 12 is not there. It's negative 6 into 3, which is negative 18. Okay. Then take the second row. This is negative 3 plus 6, negative 6. Then 4 and 0 and negative 12, which gives me this is equal to negative 1 by 12. So 6 minus 12 is negative 6 minus 18 is negative 24. This gets cancelled. This is negative 3. 4 minus 12 is negative 8. Okay, so let's divide this with 12. Negative 1 by 12, which gives me 2. And this gives me 12 to the, and this is 1 by 4. The second element is 1 by 4, and the third element is 2. It's 4 to the 8 and 4 3 the 12. So these are the values of x, y, and z. So x is equal to 2 and y is equal to 1 by 2. Y should be equal to 1 by 2. Okay, this is, let me check it. This is minus 3 and 3 to the is 6 and minus 3 into 3 is 9. This should be actually 9. Minus 9. This is minus 9. So now the 6 remains here and we get minus 3 plus 6 is 3 minus 9 is negative 6, which gives me 1 by 2. So this is 1 by 2. So x is 2, y is 1 by 2, and z is equal to 2 by 3. These are the values of x, y, and z. Okay, for question number 32, this is question number 32, part B, we have to find the product of the matrices, and hence means we have to use this to solve the following system of linear equations. So if we write these system of equations in the matrix form, it will be Ax is equal to B, and A matrix is 1, 2, negative 3, and this is 2, 3, 2, 3, negative 3, and negative 4. This is the A matrix. And X matrix will be X, Y, and Z. And B will be the matrix of the constants, which are negative 4, 2, and 11. And if we look at this matrix, this is the A matrix. And this one, uh, let's say this is B matrix. So let's multiply them. So clearly the product, if we find the product of these two matrices, this one is the A matrix. Okay, so I'm going to find the product now. The first matrix is 1, 2, negative 3. This is 2, 3, 2. And the third row is 3, negative 3, negative 3, and negative 4. This is our A matrix, and we have to find its product with this is negative 6, 17, 13, and 14, 5, and negative 8, and then negative 15, 9, and negative 1. Okay, so let's find out the product, and we know how to find the product. So, one, we have to add the product of the respective elements of the row and the column. So 1 into negative 6. So first row and first column, this is negative 6 plus 28 plus 45. This is the first element. Second one is the same row with the second column. So this is 17 plus 10 minus 27. And then 13, negative 16, and plus 3. Okay, now second row with all the columns. So 2, this is negative 12 plus this is 42 and negative 30. This is 17 twos are is 34 plus 15 plus 18, 26 to negative 24, negative 2. Okay, this is negative 18, negative 42 plus 60. 17 into 3 is 51, negative 15, negative 36. This is 39 plus 24 plus 4. Okay, so now we have the product as, so minus 6 plus 28 plus 45 is 67. So 17 plus 10 minus 27 is negative 17, so this is 0. 13 minus 16 plus 3 is 0. Negative 12 plus 42 minus 30 is 0. 34 plus 15 plus 18 is 67. 26 minus 24 minus 2 is 0. 18 minus 42 plus 60 is 0. This is 51 minus 15 is 36 minus 33 is 0. And this is 67. Okay, so this is now, I can take 67 common here. So this 67 is common. And now it's 100 0100001, which is an identity matrix. So we have got the product of this A. Let's say the other matrix was B. So this matrix was A and this matrix was B, and we have got this product as 67 into the identity matrix. So A into B is equal to 67 into identity matrix. And I can write it as A into, let's take shift 67 to this side. So this is 67, 1 by 67. So 1 by 67 into B is equal to identity matrix. Now we know that if AB is an identity matrix, then B is the inverse of A. Then A inverse is equal to B. So that means here the A inverse, A into 1 by 67 into B is identity matrix. So that means the inverse of A is 1 by 67 into B. So we have got our A inverse. So A inverse is equal to 1 by 67. Let's write down the B matrix. The B matrix here was, let's write down the B matrix, and, or let's leave it as it is. Or the B matrix was this negative 6. This is negative 6, 17, 13, and 14, 5, and negative 8, then negative 5, 9, and negative 1. Okay, this is our. Now we have to solve the following system of equations. So let's write them in the matrix form, and I have written them in the matrix form. So if we have to write them in the matrix form to solve the following system of equations, we can write them as Ax is equal to B. Okay. So we have got our A inverse. I will just keep that. Okay, now to solve this system of equations, we are going to write them in the matrix form, which is Ax is equal to B and x is equal to A inverse into B. So here x has the variables in the matrix form, and A inverse B is 1 by 67. So this is 1 by 67. Okay, and negative 6, 17, 13. This is inverse 45, negative 8, and then negative 5, 9, and negative 1. And we have to write the P matrix, which has all the constants, so negative 4, 2, and 11. So it's given in the question that you find the product of these matrices, and from there we have got the A inverse, and now we can use this to solve the following system of equations. So we have got A inverse from their product, and now we are using that to find the solve the system of equations. So let's multiply these two equations, which is equal to 1 by 67. So I'm going to multiply this. So negative 6 into 4 is 24. 17 into 2 is 34 plus 13 into 11. So 13 into 11 is 143. So this is 143. Now 14 into 4 is negative 56. And plus 5 to the is 10 and negative 88. Third is 60 plus 18 negative 11. Okay, so this is equal to 1 by 67 and 24 plus 34. This is 3 plus 4, 7. 7 plus 4 is 11. And then 4, 3, 7. 7 to 7 plus 2 is 9 and 1, 10. And then it's 1. So 24 plus 4 plus 3, 7 plus 4 is 11, and 4 plus 3, 7 plus 2 is 9, and 1, 10. So this is then 201. Okay. Now, this is negative 56, negative 56 and 88. Negative 88 gives me 14, and this is 44. So negative 144 means it's negative 134. This is 18 minus 11 is it's, so if we 18 minus 11 is 7 and plus 16 is 67. Okay, now let's divide these numbers with 67. So 60 201 is 67. Let's divide 201 by 67, which gives me, you have to divide 201 by 67. So 67 into 3. So this becomes 3. This is 3. And next is 67 into 2. 67 into 2 is 134. So this is negative 2 and 1. So we have the values 3, 2, and 1. So that means our matrix X, Y, and Z is equal to, we have got the product, which is 3, negative 2, and 1. So this is 3, negative 2, and 1. So 3, negative 2, and 1. And hence we can write that X is equal to 3, Y is equal to negative 2, and Z is equal to 1. Okay, for question number 33, we have to find the area of the region bounded by the curve. So this is the curve, and let's see what type of curve this is. And let me divide this with 36. So divide all the terms with 36. Okay, this is now 9. So finally, we have the equation of the curve x squared by 9 plus y squared by 6 is equal to 1. And I can write it as x squared by 3 squared plus y squared. This is 9. This is 36. So I can write it as 6 squared is equal to 1. So this is the equation of the ellipse, which is of the form x by x squared by a square. So this is x squared by a square plus y squared by b squared is equal to 1. And if we compare this equation with the standard equation of the ellipse, here b square is greater than a square. So that means the ellipse has its major axis on y-axis. Let me show you how. Okay. So here B is 6. If we compare these equations, so B is equal to 6 with is the semi-minor axis, and because its B is greater than A, so that means that our ellipse is on, it has a major axis on the y-axis. So this is how the ellipse is. And this is actually 0, and this should be 6, the distance. So if I mark them 1, 2, 3, 4, 5, and 6, and A is 3, so this should be 3. 1, 2, and 3. And now we have to find the area of the region bounded by the curve using integration. So that means we have to find this is the all the area bounded by the curve. So let's find out the area in the first quadrant, and we will multiply that with 2. So the required area here is equal to 4 times, because this ellipse is symmetrical about the x and the y axis. So we have four regions, 1, 2, 3, and 4, and all these are symmetrical. So I will find the area of this region, and will multiply it with 4. So let's find out the area of this region under the curve, and we'll multiply it with 4. So 4 into area of the integration will go from 0 to 3 y into dx. Let's find out the value of y. So this is 0 to 3y. And we can get the value of y from the equation this. So y square is equal to 36 minus 4x square, which gives me y. I can take 4 common here, so this is 9 minus x square, and which gives me y square is equal to 4. So this is 3 square minus x square. Okay, if I take 4 common here, this is 4 into now into 3 square minus x square, and y is equal to under root of this. So y should be now under root of this. So under root of 4's root is 2. So 2 into 3 square minus x square is the value of y. So now we have already taken 4 out here. Okay. So y square is equal to 4 into the value of y is 2. This is 2 under root of 3 square minus x square into dx, which gives me 4 to the is 8. So we are left with 0 to 3. This is 3, and integration of this is now of the form a square minus x square into dx. Okay. Now we know that the integration of the formula for integration of a square minus x square into dx is this is equal to, the formula is x by 2 under root a square minus x square plus a square by 2 into sine inverse x by a. So let's use this formula here. So which gives me a into, this is x by 2, and under root of a square minus x square will be 9 minus x square plus a square by 2, which is 9 by 2 sine inverse x by a, which is 3. And it has to be evaluated for the limits 0 to 3. Okay, so let's evaluate for it for the limits. So 8 into, let's put in the value first 3. So this is 3 by 2, and 3 square is 9, so this is 0, plus this is 9 by 2 sine inverse x is 3 by 3, and minus. So if we put 0 here, so this term is 0, and this is uh, 9 by 2 sine inverse 0 by 3 0, sine inverse 0 is 0, so this whole term is 0. Now finally we are left with 8 into, this is 9 by 2, and this is 1. This is sine inverse 1, 8 into 9 by 2 into sine inverse 1. So the angle for which value of sine is 1 is 90, which is pi by 2. So this is 4, 2, and which gives me 18 pi. So this is 18 pi square units is the area of the required region. Okay, for question number 34, part A, we have to find the coordinates of the foot of the perpendicular drawn from the point 2, 3, -8 to this line. Equation of the line is given in the Cartesian form. So let's visualize this problem first. Let's say this is the perpendicular drawn from the point 238, and this is the given line with the given equation, and this line is drawn from the coordinates 2, 3, and -8 to the line. This is 4 minus x by 2 is equal to y by 6 is equal to y minus z by 3. Now let's get this in the standard form. To get this equation in the standard form, or yes, let's get this in the standard form, because the standard equation of the line in Cartesian form is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So if we take negative out here, so this is x minus 4 by -2, it's equal to this is y by 6, this is z minus 1 by -3. So now this is the standard equation of the line. Okay, now let's say this is equal to lambda. So let's equate this, all these to lambda, and get the values of x, y, and z. So x minus 4 by 2 is equal to lambda gives x is equal to, this is 4 minus 2 lambda. And similarly, if I equate this to lambda, which gives me y is equal to 6 lambda. If I equate this to lambda, which gives me z is equal to 1 minus 3 lambda. So we have the values of z, y, and x. And let's say for some value of z, for some value of lambda, this be the foot of coordinates of the foot of the perpendicular. So coordinates of the foot of the perpendicular be, let's say 4 minus 2 lambda for some value of lambda, and this is 6 lambda, this is 1 minus 3 lambda. So 4 minus 2 lambda and 6 lambda and 1 minus 3 lambda. Now, okay, so we have got the coordinates of the foot of the perpendicular for some value of lambda. Now, let's say this is line AB. So what would be the direction ratios, or the direction ratios of line AB? So I'm going to write down the direction ratios of line AB, which are given by x2 minus x1, comma y2 minus y1, and z2 minus z1. If you know the coordinates, so this is x1, this is let's say x2 and x1. So 4 minus 2 lambda minus 2. So x2 minus x1. 4 minus 2 lambda minus 2. So this is, let's say, x2, x1, x2, y2, z2, and x1, y1, z1. So 4 minus 2 lambda minus 2 will give me 2 minus 2 lambda. So this is 2 minus 2 lambda. Similarly, 6 lambda minus 3. So 6 lambda minus 3, and z2 is 1 minus 3 lambda. Minus of minus 8 is 1 minus 3 lambda plus 8, which is 9 minus 3 lambda. So this is 9 minus 3 lambda. So these are the direction ratios of AB. Okay, similarly, let's write down the direction ratios of line. Let's say this is line C, or this is, let's say, line L, and its equation is given to us. So its direction ratios are here. The direction ratios of line L, these are negative 2, 6, negative 2, 6, and negative 3. Now AB is perpendicular to L, so that means A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0, where these are the direction ratios A1, B1, C1, and these are the direction ratios A2, B2, and C2. So let's multiply them. So 2 minus 2 lambda into negative 2 is negative 4 plus 4 lambda. B1 into B2, 6, 6 r is 36 lambda minus 18 plus negative 3 into uh, uh, 9 is negative 27 plus 9 lambda is equal to 0. Okay, so this is 36 lambda plus 9 is 9, 6, 36 plus 36, 4 plus 36 is 40 plus 9 is 49 lambda, and negative 4, negative 18 is negative 22, negative 32, and negative 27 is negative 49, which is equal to 0. So which gives me 49 lambda is equal to 49 and lambda is equal to 1. So we have got lambda, and let's write down the coordinates of the foot of the perpendicular. So coordinates of foot of perpendicular are coordinates of foot of perpendicular are. Let's put in the value of lambda here, which were 4 minus 2 lambda. So which were these were 4 minus 2 lambda common, comma, and 6 lambda, and was 1 minus 3 lambda. Okay, let's put in the value of lambda here, which is 1, 4 minus 2, 6, and 1 minus 3, which gives me 2, 6, and negative 2. So 2, 6, and negative 2 are the coordinates of the foot of the perpendicular. Now we have to find the perpendicular distance as well. So we have got the coordinates and we can use the distance formula. So coordinates of B are 2, 6, negative 2. So here the coordinates are 2, 6, and negative 2. And we have to find the perpendicular distance from the given point. So perpendicular distance from the given point can be, you can find that using the distance formula. So this is 2 minus 2 is 0 square plus 3 minus 6 is negative 3 square plus negative 8 minus of minus 2 is negative 6 square under root using the distance formula. So this is 9 plus 36, which is 45, and I can write 45 as 9 into 5. So this is 3 root 5 units is the perpendicular distance. Okay, for question number 34, part B. This is question number 34, part B. We have to find the shortest distance between the lines L1 and L2, the line passing through 2, negative 1, 1, and parallel to this, and L2 has the vector equation. And we know that the shortest distance between the lines is given by, so shortest distance between two lines is given by A2 minus A1 vector, where A2 and A1 are the position vectors of the point through which the line is passing. And we have to find its dot product with B1 and B2. B1 and B2 are the vectors that are parallel to the given lines. And we have to define their uh, dot product and take the positive value, and we have to divide this with the magnitude of the cross product of B1 and B2. Okay, so let's find out what line L1. The line L1 is passing through this. So its position vector is, this position vector is 2i cap minus j cap plus k cap. And it's parallel to this line. So it's parallel to this line. So that means our B1 vector has, these are the direction ratios, and equation will be I cap plus j cap plus 3k cap. So line L1 has the vector equation. So let me write down the vector equation of the line L1, which is equal to A1 plus lambda into b1 vector, and is a1 is the position vector of the point through which it's passing. So 2 I cap minus j cap plus k cap plus lambda into b1 vector is I cap plus j cap plus 3k cap. So this is the vector equation of the line L1. And so this is a1 vector. Let's write down the a1 vector, which is 2 I cap minus j cap plus k cap, and b1 vector here is I cap plus j cap plus k cap. Okay, now for line L2 has the equation. It has the vector equation. So it's, let's say this was R1, this was R2 vector, and it has the vector equation I cap plus j cap negative 2k cap, so the negative 2k cap plus mu into 2j cap minus k cap. Okay, so this is our A2 vector. So A2 vector is I cap plus j cap minus 2k cap, and B2 vector. And this is the B2 vector, which is equal to 2j cap minus k cap. Okay, now let's use the formula. Let's find out A2 minus A1's dot product with B cross B2. So let's find out A2 minus A1. So A2 minus A1. A2 minus A1, this is A2, this is A1. So I cap minus 2 I cap is negative I cap, and J cap minus of minus J cap is plus 2J cap, minus 2K cap minus K cap is minus 3K cap. This is A2 minus A1. Okay, now let's find out B1 cross B2. B1 cross B2 is I cap, J cap, K cap, and the determinants of this is B1, so 113, 113. This is B1. Take the scalar components 113, and B2 has a scalar components 0, 2, and negative 1. So this is 0, 2, and negative 1. Let's find out the cross. So this would be I cap, and determinant left is 1, 3, 2, negative 1, then negative j cap. Find the determinant along the first row to negative j cap, and remove the row and the column for the j cap, which is 1, 3, 0, and negative 1 plus k cap. Remove the row and the column for the k cap. So this is 1, 1, 0, and 2. Okay, this is now equal to I cap 1 into negative 1 is negative 1, negative 6, negative j cap, negative 1 and 0, plus k cap 2 and 0. Okay, finally, this is B1 plus B2, which is equal to negative 7 I cap plus j cap plus 2k cap. So this is B1 cross B2. Okay, now let's find out the dot product. Let's find out the dot product of A2 minus A1. So dot product with B1 cross B2. So A2 minus A1 was, let's write down A2 minus A1, which is negative 1 plus 2j cap minus 3k cap. So dot product with negative 7I cap plus j cap plus 2k cap. Okay, and how do we find the dot product? Just find the product of the respective scalar components. So negative 1 into negative 7 plus 2 into 1 was negative 3 into 2, which gives me 7 plus 2, negative 6, and which is equal to 3. So this is 3. Okay, now let's also find out the magnitude of this, which is equal to negative 7 square plus 1 square plus 2 square, and it's under root. So this is 49 plus 1, 1 plus 4. So 49 plus 4 is 53 plus 49 plus 4 is 53 plus 1 is 54. So B1 cross B2, the magnitude is negative 7 square 49, 1 square, and 2 square is 4. So 49 plus 4 is 53 plus 1 is 54. And let's put these values in this formula now. So this is equal to A2 minus A1 minus B1 cross B2 was 3. So this is 3 divided by under root of 54. So I can write this under root of 54. This is 9 into 6. And this is now 3 root of 9 is 3. And this is under root 6. So this gets cancelled. So 1 by root 6 units is the perpendicular distance. Okay, for question number 35, we have to solve the linear programming problem graphically for maximize z subject to the constraints. This is the objective function and these are the constraints. So first of all, let's plot the graph for this. And I'm going to take the scale as 2. So 0, 2, 4, 6, 8, 10, and 12. Similarly here, it's 2, 4, 6, 8, 10, and 12. Okay, now for the first one, that is x plus 2y is equal to 12. If I put x is equal to 0, which gives me y as 6, and I put y as 0, it gives me x 12. So my coordinates are 0, 6, and 12, 0. So 0, 6 is here, and 12, 0 is here. So this is 12, comma 0, and this has the coordinate 0, comma 6. So let me join them. Okay, so this is for x plus 2y is equal to 12. Now, if I check this equation for the origin 0, comma 0, which is here, so this gives me 0 is less than 12, which is true. So that means it has a solution region towards the origin. And now let's plot the graph for 2x plus y is equal to 12. So 2x plus y is equal to 12. If I put x is equal to 0, which gives me y is equal to 12. And if I put y is equal to 0, which gives me x is equal to 6. So I have 0, comma 12 is here and 6, comma 0 is here. So let me join them. So it's 12, comma 0 and 6, comma 0 is here. Join them and I will have this. So this is 2x plus y is equal to 12. And if I check this 2x plus y is less than equal to 12 for 0, comma 0, which gives me 0 is less than 12, which is true. So that means its solution region is also towards the origin. So it's also coming towards the origin. Now for 4x plus y is equal to 20. So 4x plus y is equal to 20. So 4x plus, sorry, 5y is equal to 20. So if I put x is equal to 0, which gives me y is equal to 4, and for y is equal to 0, which gives me x is equal to 5. So 0, comma 4 is here, and 5, comma 0 is here. And let me join them. So which gives me equation of the line, this one. And if I find out the solution region for this one, if I check this equation for 0, comma 0, so 0 is greater than 20, which is false. So that means its solution region is away from the origin. So its solution region is away from the origin, and we have our common region. So this is our common region, this one. and let's say its corner points are, so I'm going to write down its corner point. Let this be A, let this be point A, this be point B, this be C, and this be D and E. So actually I have five corner points. So corner point A. So corner point A has the coordinates 0, comma 4. So this is 0, comma 4. B has the coordinate 0, comma 6. And C has the coordinate 4, comma 4. Now D has the coordinate 6, comma 0. And E has the coordinate 5, comma 0. Okay, now let's find out the value of Z for this. So Z was 60x plus 40y. Okay, so for C, this is C, which has the coordinates 4, comma 4. So this is 4, comma 4. This is A, B, C. This is D, which is 6, comma 0. This is E, which is 5, comma 0. Now let's find out the value of Z for all these. So here Z is 166. This is 240. This is 400. This is 360. And this is 300. So maximum value is 400. This is the maximum value, and it's at x is equal to 4 and y is equal to 4. Okay, for question number 36, part A, these are three case study based questions of 4 marks each. And the first one is given to us, which says that students of a school are taken to a railway museum to learn about railways, heritage, and history. And an exhibit in the museum depicted many rail lines on the track near the railway station, and L with the set of all rail lines on the railway track, and R with the relation. So the relation says that two rail lines are in relation when they are parallel to each other, and on the basis of the information we have to answer whether the relation is symmetric or not. Okay, so our relation is R. So for the first one, which says the two rail lines are in relation L1 and L2, they are in relation when L1 is parallel to L2. And we have to check whether it's symmetric or not. So let's say L1 and L2 belongs to relation. So that means L1 is parallel to L2. If L1 is parallel to L2, then we can change the order, that is L2 is parallel to L1. Now L2 is parallel to L1 according to the relation will give us that L2 and L1 belongs to relation. So L1 and L2 are in relation, which gives us L2 comma L1 is in relation. So that means that R is symmetric. Okay, for the second one, we have to check whether it's transitive or not. So for transitive, let's say L1 and L2 are in relation. And then L2 and L3 are in relation. So if L1 and L2 are in relation, which gives this gives that L1 is parallel to L2, and this gives that L2 is parallel to L2. Now, there are three lines, L1, L2, and L3. This is L1, L2, and L3. L1 is parallel to L2, L2 is parallel to L3. Now, the two lines parallel to the same line are parallel to each other, which gives us, so this implies that L1 is parallel to L2. So if L1 is parallel to L3, which shows that L1 and L3 are in relation. So if L1 and L3 are in relation, so that means the relation is rounded. Okay, for question number third, it gives that one rail lines on the railway track. So there is a rail line on a railway track, which is represented by the equation y is equal to 3x plus 2. Now this is the equation of the line in the form y is equal to mx plus c, where m is the slope of the line, so slope of the line is 3. Now we have to find the set of rail lines in are related to it. So the rail lines which are related to this that has the equation 3x plus 2 will be all parallel lines, and we know that the parallel lines have slope equal to 3. So that means the the lines that will be related to this line, let this be L1. So L2 will be the set of all lines that has the slope 3. So they will have the equations y is equal to 3x plus c, where c is the x-intercept. So I can write that. So all the lines which have slope 3 will be parallel to this line because the slope of the parallel lines is equal. So the set of real lines in R related to it, I can write it as, so set, if you have to write that in the set form, so set L2 will be the set of all lines. So L2 will be all lines. Now L2 is a line, or I can take it at LL as well. So L is a line uh, such that has the equation y is, so L2 is a line that has the equation such that L2 has the equation y is equal to 3x plus c, where c belongs to any real number. So this is a set of all lines that will be in relation to this line, because this has, all these lines will have slope 3, which is parallel to this line. Okay, for the part B, that is or, now S, there is a relation S that is defined by L1 and L2 has two pairs, and they are in relation if they are perpendicular to each other. We have to check whether it's symmetric or not. Now L1 is in relation with L2. So this implies that L1 is perpendicular to L. If L1 is perpendicular to L2, so that means we can say that L2 is perpendicular to L1. And if L2 is perpendicular to L1, then according to the relation, L2 and L1 are in relation. So L1 and L2 are in relation, which gives that L2 and L1 are in relation. So R is symmetric. Now we have to check it for transitive. So for transitive, we have to, let's suppose that L1 and L2 are in relation. So, and also L2 and L3 are in relation. So L1 and L2 are in relation. So relation is S. So we have to write that it's S. So it's S. Relation is S. So S relation is symmetric. So they are in relation S. So according to the relation S, with this gives us that L1 is perpendicular to L2, and this gives us L2 is perpendicular to L2. So let's try to visualize this. So let's say this is L1, which is perpendicular to L2. So this is L1, which is perpendicular to L2. And now L2 is perpendicular to L3. So L2 is perpendicular to L3 means, let's say this is L2, L3, and this is L. Okay, this was L2, this was L2. Let's say this is L3. So L2, sorry, this was L1. Okay. L1 was perpendicular to L2 and L2 is perpendicular to L3. So that means L1 and L3 are parallel. So this gives us that L1 and L3 are parallel. So this implies that L1 and L3, they don't belong to relation S. So that means S is not transitive. So it's symmetric, but it's not transitive. Okay, for question number 37, it's given a rectangular visiting card is to contain 24 square centimeter of printed matter, and this is the printed matter. और जो प्रिंटेड मैटर है उसके टॉप और बॉटम पे मार्जिन जो होनी चाहिए वो है 1 सेंटीमीटर टॉप एंड बॉटम पे, और जो मार्जिन लेफ्ट और राइट पे है वो है 1.5 सेंटीमीटर्स. These are to be left at the left, right at the left. um, so this is the printed matter. which has the length x and y. Now we have to write the expression for the area of the card in terms of x. So area of the card means the whole area including the printed matter and the uh, area of the margins. So that means this card has the length, its length would be, so we have to add x plus half centimeter and half plus half is 3. So this is x plus 3 centimeter is the length of the card, and the breadth of the card would be, we have to add one on the top and one on the bottom. So this is y plus 2 centimeter. So that means let AX be the area of the card. So AX with the area of the card, which gives me length into breadth, which is in the rectangular form. So L into B, which gives me x plus 3 into y plus 2 centimeter square. And let me open this up. So this is xy plus 3y plus 2x plus 6. Okay, so this is xy plus. Now, it's given that it contains the printed matter's area is 24 square centimeters. So this is the printed matter. So area of the printed matter is this one. Its length is x and breadth is y. So its area is xy, which is given as 24 centimeters square. So I can put the value here. So area of the card is in terms of x is 24 plus 6 is 30. So this is 24. So 24 plus 6 is 30. So 30 plus 3y plus 2x. And we have to get this in terms of x. So now xy is equal to 24. I can get the value of y, which is 24 by x. Let's put in the value of y here. So area in terms of x is equal to 30 plus 3 into y is 24 by x plus 2x. Okay, which gives me an area in terms of x is equal to 30 plus 3 into 24 is 72 upon x plus 2x. This is the area in terms of x. Now we have to obtain the dimensions of the card of minimum area. Okay, so our area in terms of x is 30 plus 72x plus 2x. Let me differentiate this with respect to x, which gives me differentiation of 30 is 0. This is 72, and differentiation of 1 by x is negative 1 by x square plus 2. 2x is 2. So area in terms differentiation is negative 72 by x squared plus 2, and let's find out the critical values. So for minimum area, a dash x should be equal to 0. So a dash x should be equal to 0. Let's find out a dash x. So a dash x is already there. So negative 72 by x squared is equal to negative 2. This gets cancelled, and x squared is equal to 144, which gives me x is equal to plus minus 12. So this is plus and minus 12. X is plus and minus 12. This is 2 minus, okay, actually this should not be 44. This should be x squared has to be divided, 72 divided by 2, this is 36. So x is plus minus 6. So this is 6. The critical point is 6. Now let's check when x is equal to 6. So let's find out the second order derivative here. So a double dash x is now equal to, so this is negative 72 into its minus 2 by x cube, which gives me 144 by x cube. And for x is equal to 6, a double dash second order derivatives value is 144 by 6 cube, which is greater than 0. So that means that area is minimum when x is equal to 6. So x is the length of the printed matter. So X is the length of the printed matter and Y. So Y is equal to 24 by 6, which is equal to 4 centimeter. So to get the minimum area, the length and the breadth of the printed matter should be 6 and 4, but we have to find the dimensions of the card. So the length of card, we have to add 3 in it. 6 plus 3 is equal to, so this is the length of the card of minimum area. So 6 plus 3 is equal to 9 centimeters. And the breadth the card will be 4 plus 2 is equal to 6 centimeters. So this is for the minimum area of card. This is the dimensions for minimum area of cards dimensions. So length is 9 and breadth is 6. Okay, for next question, that is the last question of this set. A departmental store sends bills to charge its customers once a month. So, and past experience shows that 70% of its customers pays their first month bill in time. And now, uh, when the store pulls up the data, they found that the customer who pays the bill in time has a probability of 0.8 of paying in next month. And the customer who doesn't pay in time has a probability of zero point 0.4 of paying in the time next month. So this is the probability of paying it in the second month. And based on the above information, we have to answer the following questions. E1 and E2 are the event of customer paying or not paying the first bill month in time. So what is the probability of E1? So probability of E1 is, so it's given here that 70% of its customers pay their first month bill in time, and even denotes the same event of customer paying first month bill in time, which is 70%. So probability of E1 is 70%, and I can write it down here. So for the first one, its probability of E1 is 70%. That is, even denotes the customer paying the first month bill in time, which is 70% in time. So which is equal to 7 by 10. That means it's zero point 0.7. Now, who do not pay the first month bill in time. So do not pay the first month bill in time will be 30%. So E2 is the probability when the customers do not pay the first month bill in time, which is 30%, is equal to 30 by 100, because 70% pay in time, but 30% do not pay in time. So this is 3 by 10, which is equal to zero point 0.3. Okay. Now the second question is we have to find the probability. So A is the probability, sorry, it's given that the A denotes the event of customer paying second month's bill in time. So we have to find the probability of paying the second month's bill in time when the customers had already paid first month's bill in time. The probability of A by E1. So this is point A is the probability of paying in time next month. So this is zero point 0.8. And the probability of paying next month's bill in time when the customers have not paid the first month's bill in time, which is zero point 0.4. Now, this one is done. Sorry, this one is done. We have to find the probability of customer paying second month's bill in time. There is no condition applied here. So we are just asked what is the probability of A. So we have two type of customers who pay their bill in time and who do not pay their first month's bill in time. So this is the probability of E1 into probability of paying second month's bill in time when first month's bill in time has been paid, and probability of E2 when second month's bill in time is not paid. So probability of paying the second month's bill in time when first month's bill in time is not paid. Okay. So let's put in the respective values. Probability of E1 is zero point 0.7 and this is zero point 0.8. This is zero point 0.3 and this is zero point 0.4, which gives me 0.56 plus 0.12, which is point, this is 68. Okay, now the OR part. Okay, our part says that we have to find the probability of customer paying first month's bill in time, which is E1. And the condition applied here is that customer has paid the second month's bill in time. Second month's bill in time is A. So we have to find the probability of paying first month's bill in time when second month's bill in time has been paid. So we have to find out E1 by A, and using the base theorem, it's P probability of E1 into probability of A by E1 divided by probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2. Okay, let's put in the respective values. So probability of E1 into probability of A1, it's 0.56. So this is 0.56 upon 0.56, and probability of E2 into probability of A by E2 is 0.12. So this is 0.12, which gives me 0.56, and this is point 5 plus 1 is 6.68, which gives me 56 by 68, and this is 28 by 34, and then 7, then 14 and 17. So the probability is 14 by 7. You like, share, and subscribe. Thank you for watching.